Can hear, yeah, in Discord we can. I can hear in Discord. Might just be a muted thing. He's just sorted his mic out. If you can hear me. Oh, can you hear me on YouTube?
How's that? Is that better? Can you hear me now? Can you hear me now? Yes.
Yep, you're good.
Jolly good. On YouTube, good. You can hear spot on. That's good. Yeah, you can hear me now. I think you're a little bit behind. Let everybody come back because there was a few people watching. Don't want anybody to miss anything. Going through thank you very much. Yeah, I don't know what happened there. Some sort of a PC update, I think. I think Steam doesn't like updating, but I would expect that Discord had an update as well at the same time. I think. Go back in Discord. Let's have a look. Everybody in Discord's still here. Give a few more people a bit of chance to come back again. Yeah, going over. You guys in Discord are going to want the screen back again.
I wonder if Effie Dogman's. If you are, go on in. Because, you know, you're putting people's names to things that he shouldn't be doing.
Yeah, he's been telling everybody he was banned, but his name's still in here. We've been tagging him ever since we started doing it. Right. So, everybody else come back. Still only 13. Are they numbers? Are they right? Yeah, I don't know what happened.
I'll see. Let me go on YouTube as well.
I don't know what happened with that stream back then.
Well, the usual, you know, when you're on a hot topic, it seems to
yeah.
But that happens a lot. It seems.
Right, they're on Twitter. They're going on about the twin tangents. It's fantastic. Some of this geometric stuff that we're going over. Sort of exactly what we want, really. In order to oh,
excuse me.
Done. Done and close that.
I think you lost audio just a little bit before that, but where we're at now on there. I think you're at 4 minutes. It may have just been like 30 seconds or so before.
Let me just get the level logo off to go because I've reset all of this. With you guys, about here somewhere. I'll go back. It's only 3 minutes.
529.63 feet is the smallest elevation. I am going to use that as my curved level line. Now I'll add the
Oh, it sounds weird when he says that. Curved level line. Like they've made it normal. Strange.
Did he say my level?
Yeah, but there aren't many.
Yeah. My curved level line is what he said.
There's not many, you know, talking of these things. That's the thing, I think, to be aware of, everyone. Just, well, people that create shit like this.
Yeah, this is particular to this globe hypothesis. There's no other place that you will ever hear anything like this. Not in reality, not any surveyors, never at the side of the canal or talking to anybody, you know, at a pub. You just don't talk of this sort of stuff because this literally makes you sound crazy.
Anyone who thinks level curves is obviously not in construction.
Yeah.
Concrete
There you go.
slab, which is the equivalent of that horizontal line tangent to the end station. And finally, I'll add the other 4 elevations. So next I'll be using earth curvature calculations, which are based on Pythagorean theorem. And of course that requires a horizontal line tangent to the surface of the earth, which would be the equivalent of a level line.
Right, yeah, I pointed it out last time. Don't know whether you guys heard or not. It's Pythagorean proof, i.e. triangles. He's making triangles here.
Mm-hmm. Yeah.
And I don't know whether you guys did see this. Did you see? Can you see that there? Read what it says.
Yes, therefore triangles have at least one curved side.
No, it's Pythagorean. The drop, horizontal, vertical.
Yeah. Yeah, but the bit between, the bit between where the arrows are, the point of tangent they've got there, where it touches the curve, that's a straight line, not a curve.
Yeah, the Pythagorean proof
yeah.
is this triangle here, this one, and then straight back to here.
I can't see your cursor.
Oh, can you not?
Can anyone else? But,
yeah, maybe not in Discord.
But...
Yeah, but can you see what it says here on just to the left of the tangent? It says, imaginary ball earth.
Is that what that word is?
That's what it says there. Imaginary ball earth.
Can't see it. Okay.
So that's what this is here. And then you using triangles and straight lines here.
Mm.
That's all you do.
It's, like you say, it's just the rise over run or like drop from the horizontal. Yeah. An elevation change.
Well, a horizontal and a vertical. It's like rise over run calculations within Pythagorean theorem.
Yeah, if you want to know the drop from there to there, set your instrument up. I mean, they've obviously got the scale all wrong here again, as like the last drawing he did. Where the guy's, he must be a giant. But anyway, yeah.
Yeah, these are the numbers you have to fit to, right? The moment you put this here and do this, then these are the numbers you're confined to. These drop numbers of this level line away from the horizontal that's measured. They'll tell you it's measured. Because they don't know anything about surveying and they've trusted certain people, we'll call them conveyors, from YouTube that have made videos that have been very vague. People believe that this is a measurable thing. The water drops in the distance and it's measurable with a horizontal. Absolutely ridiculous, but some people go with the fantasy, the imaginary ball earth model. And all of these are the numbers they have to fit to. There's no choice. This Pythagorean proof of curvature, this Pythagorean formula, is a must-do situation. It's a model dictates these numbers from here on in. They're stuck to it. Can't get away from it.
Of course, the curvature drop calculation is measured from the horizontal line down to the level line. And this is the reason that I said these beam arm slabs are horizontal and in this case tangent to the end station.
See? The beam slabs are horizontal. That's what he said.
Yeah, this one here though, he's got it from the end station on the left, doesn't he? Showing the drop on the, the end of it is, is that right? Is that what you're saying? There's a drop.
Well,
the tangent is at the station, and then there's a drop at one end from a horizontal line. I mean,
he's put horizontal on it.
Yeah.
So the LIGO arm, he says, and he says vocally, it is horizontal, right? The fact that we say, when I say level is horizontal, I mean horizontal is there. That's establishable by tools.
Yeah.
Level is the same thing.
Just because there's a drop.
Well, they think there's a drop. They think this level, it goes down here, it drops. And they call that difference curvature drop. But it's not curvature drop. It's a measured vertical.
Yeah.
That's it.
Yeah.
But, I mean, it's not a measured vertical, as they'll tell you. Because they know they can't measure it. It's interesting.
Yeah, because they've got the same distance there. They got the. I'm sorry, I'm struggling to see it. So you got 52963 feet, and then the other end you got 52963 feet.
Mm-hmm.
And then you've got above it 53378 feet.
Yeah, they've got a horizontal line, right? Remember this, mathematically.
Level.
Yeah, mathematically, a horizontal line has 0 slope. 0. If it's not got 0 slope, it's not a horizontal line. Yet, he labels it horizontal. It's got 529 feet at this end, and this end, 533. There's a 4-foot difference along a horizontal line.
Yeah.
Not possible. Impossible. Ridiculous.
Got level line curving, which should be straight, and a straight line straight that's showing it should be curving.
Well, it's showing that it should have a slope to it.
Yeah.
There's an elevation
sorry,
change
not,
on
not,
it.
sorry,
Yeah.
not curving. Yeah, sorry. Yes.
Interesting. Funny numbers.
Crazy.
Funny numbers.
I use Metabunk for my curvature calculations, and of course that's based on a radius of 3,900.
Metabunk. Really? The
You
curvature
broke that word down the
calculator.
other day, didn't you?
Yeah, meta is beyond. It's like in the future. It's like way
understanding.
better. Yeah. Thinking about it way more. And bunk is just a load of shit. Rubbish.
Thinking about shit a lot
Nonsense. Yeah. Way deep into the bullshit and the nonsense. Metabunk. Curvature calculator. But it's not a curvature calculator at all. What it does, it allows you to know the amount of curvature that mentally you need to put into a horizontal to imagine you can live on a globe.
And it is also refraction involved in this calculation.
Well, refracted, yeah, maybe. But I mean, it's still the amount of curvature that you can give a level line to imagine you live on a globe. This is completely derived from globe. And this horizontal line, everybody knows the horizontal line is there in reality. Even FE Dogma's not getting rid of it.
Well, locally, obviously, anyway, you're allowed to use it according to them.
No, you're not.
Even the model Afflicted, aren't you?
No. Rumpus will be after him. Rumpus will be telling this guy off. You can't mark horizontal line on graphs anymore if you're a glober. You're just not allowed.
Oh, they've started. I think it was Alpha that mentioned. You got some graph paper, and then you just roll it up.
Mm-hmm. Yeah, pick it up and move it. Yeah. Mm-hmm.
159
Nice one,
miles.
Alpha.
So my curvature calculations are going to be based on the distance from the end station.
So he's now going to do some curvature calculations. Of what? Well, the horizontal line. He's going to start off with the horizontal line And he's then going to do some curvature calculations to work out some stuff. Let's go.
First calculations based on a distance of 0.606 miles, which gives us a drop of 0.24 feet. And when I subtract that from the beam slab elevation, that gives me 529.64 feet. And when I compare that to the level line elevation of 529.63 feet, the difference is only 0.01 feet. That's less than 1/8 of an inch. The next calculation is based...
Right, remember here, LIGO and the concrete beam is real. That has been built. It is straight. All of the other things are imaginary. The only thing that is real in all of this is the concrete slab that has definitely been built and the LIGO arm. They're real, definitely real, and claim to be horizontal. The calculations and everything else that's coming on top of this now are just calculations from the straight line that is already there.
On a distance of 1.231 miles for a drop of 1.01 feet. And we subtract that from the beam slab elevation, we get 529.65 feet. And we have a difference of 0.02 feet, but that's only less than 1/4 inch. The next calculation gives us a drop of 2.3 feet, which again gives us 529.65 feet. And again, this is less than 1/4 inch. And finally, we have a calculated drop of 4.1 feet. Subtract that from the beam slab elevation, and we have 529.68 feet. And here the difference is 0.05 feet, but this is less than 5/8 of an inch. So let's think about this. I set this up using survey and definition of horizontal and level lines, and then I made metabunk curvature calculations, subtracted those from the beam slab elevations, and the accuracy is under 5/8 of an inch. Now I did the exact same thing for the southwest arm, and in this case the accuracy is less than 1/2 inch. Let's compare
His accuracy of something that wasn't there. His calculation of a level line underneath the LIGO tubes that he had as horizontal but with an elevation change. And he was within 1/2 inch. Which is interesting. Because this is where he moved the tangent. It's at the corner station.
Yeah.
We skipped over it really quickly. Look. Tangent at the corner station. Move it back here. Oh. The tangent's here at A. And this is the corner station. With no tangent on it. They've got a drop. We'll just move it a little bit further forward. Oh, it is the corner station with a tangent on it.
Just do that again one more time, Ben, please. So you got north direction there.
Mm-hmm.
Then you got north direction there.
Yeah, here you've got north pointing this way.
Yeah.
At the top. And then, oh, the guy's at the thing, you can't see it. And then when he turns his arm, I've got the corner, and look, the north's pointing down this way now. Here's the corner point.
This indicator.
Mm-hmm.
He changed.
Yep.
In that drawing,
it was
he
over
changed
it.
Yes, on original it was wrong.
Yeah, because I pointed it out. So he has noticed that. I don't know whether he pointed it out that it was probably us that pointed that out, that he made that change. But good on you, FE Dogma. At least you've let everybody know that you have actually turned the arms round. So this one here, he has got the tangent at the corner station.
Yeah.
He's got two
Are they
tangents.
Sorry, they both coming from the corner now. Sorry, I'm not quite keeping up with that bit. I got a bit confused.
No, it's here. The tangent's
So
on the end station of this one.
Or is he just showing it that way and flicking the drawing round? Like, are they opposite? Because he's got...
It's the other arm.
Yes, he didn't flip the bottom drawing. That in that way, the viewer can think that this is the same tangent, but it is not. But if the viewer could not see that he rotated the upper part of the drawing, the viewer could think that this is the same tangent point.
Now, does their model function have a quadratic within the drop function? I.e., if this tangent carried on going down here and were to go past this point, it would increasingly get further and further away from this point, wouldn't it?
Yeah. Ever increasing circles.
Now, what would happen if you reset the tangent point? Sort of like doing a 1600 meter water level in 16 100 meter segments. Did you think you'd get the true number at the end? Supposing you were to just put another tangent point right at the corner for your other line.
It would change the drop rate.
It would, wouldn't it?
Calculations.
Yeah. So now I'm not too sure, and I don't want to say too much here, but what this would say to me is the person that wrote these numbers in the first place used the method where he moved the tangent point in order to calculate what numbers would be needed for him to write down on a thing for this particular model. Because some globe earthers probably might want to come and just check the numbers and make sure. And what they'd have to do then, in order to get these numbers to work out to ish correctness, they would have to move the tangent point from one place.
Not only that, they
Another
would
place.
have changed to tangent point, but they would have to change a horizontal line, not parallel to original horizontal line. This is the problem.
Well, look. Concrete slab equals horizontal line tangent to corner station. Tangent to corner station. Concrete slab, horizontal line, tangent to corner station. What was the one before that? Concrete slab equals horizontal line, tangent to end station. So this tangent here goes from here, this end station, all the way to here, horizontally, and then it picks up from here and goes horizontally from the corner station. He's got two tangents on one line. It's here. There's a tangent here and a tangent here. He's got a horizontal concrete slab going all the way there. And then he's got it horizontal all the way from there down there. Simple. And now, any budding mathematicians here? If you were to not double up on the tangent point, just use one, like traditional mathematics, do you think These numbers might work if you start off with this first one and it's out at 5/8 of an inch. But if you go here and you do not reset your tangent point, how far out do you think this would be over here? Within the calculations of the globe model, providing you do not reset the continuing quadratic function, do you think it'd still be within half an inch?
No, would be bigger.
Mm-hmm.
And every point, new point, it would be bigger. Difference would be bigger.
So what this shows to me is the person that he's got these numbers off, or whether F.E. Dogma knows the person that did them, but he definitely knows the method of doubling up on the tangent point. That's why he's put 2 tangent points on here. There could be no possible reason for it. If he did not put 2 tangent points on this drawing, these numbers would not match up, signifying that the person that originally plotted these numbers or gave the numbers to whoever used this twin tangent method. It's the only way it's possible. So thank you, F.E. Dogma. Some people might be able to work out mathematically, because it's a puzzle. Not only the initial puzzle of the twin tangents, but advanced quadratic function problems for the budding mathematicians, the ones that like typing numbers and putting in calculations of what models fit what. Look into it, try and work it out. See whether the numbers have fit with one tangent and where you could put the tangent in order to get these numbers to fit. Or whether you just deal with the horizontal. You probably end up just dealing with the horizontal. It'd be easier.
½ inch. Let's compare both models. Up above, we have the Bev flat Earth hypothesis, and this gives us a beam slab that curves over 4 feet higher from one end to the other. Down below,
utterly ridiculous. Look at it. Water level being horizontal, and then he's linking that to this upward curve. That's ridiculous. I do not. This has got nothing to do with me. Even though he's putting my name on it. Fucking ridiculous.
Below, we have the globe hypothesis, and here we have a beam slab that is straight with an accuracy that is under 5/8 of an inch. Well, I really doubt that this was just random chance, because in geodetic surveying, level lines of equal elevation are curved lines.
Did you hear that? In geodetic surveying, claims this man, level lines of equal altitude are curved lines. It's a bold claim to make. Bold claim.
Yes, and he's saying that if you are assuming this Bev/flat Earth hypothesis, you will end with error of 4 feet.
Yeah.
And if you are choosing globe model, then you will be under 5/8 inch. So you are making a lesser mistake if you are choosing globe model. Therefore, this globe model has to be better.
Yeah, he says here, were the accurate metabunk curve calculations just random chance? I say no. I say the person that wrote the numbers down, the ones that have told you there is a 4-foot slope to a horizontal line, I say those people are the ones that are a little bit off, maybe. Maybe it's just somebody writing some numbers down. I mean, who knows? What we do know is some other people have made a video that states the water level drops away from the horizontal because of these numbers that they've found somewhere. It's a very, very bold claim to say that the water level drops away from the horizontal, and that's what makes LIGO a straight line.
That's ridiculous statement.
Well, maybe me saying that, but I mean, that's what he is saying. It's this globe hypothesis, level lines are curved. That makes LIGO into a straight line. Because if you think level is straight, he's got it curving for some reason.
Yes, that's why when they are making straight level, which for them is curved, then they are curving a straight line. I mean LIGO.
Chikey's got a bit in this. Well done, Chike. Good to see you back in the YouTube chat.
When Bev reviewed my video, did he show that the elevations, my calculations, or any of my diagrams were wrong?
No, I'm just basically on about the fundamental geometry. I'm not bothered about his calculations.
Do you remember, Bev, when when this all came about LIGO, and someone had said that there was a 4-foot drop at the end of LIGO.
Mm-hmm.
That's, you can see the curvature from the actual tube itself. There's a drop, and that's an elevation change.
Yeah.
Of 4 foot.
Mm-hmm.
This isn't what this guy's doing, is it? Or is it?
Well, it is, but what they don't say is that the double nutsack coming back again. This guy never talks about it coming back the other way. He's completely forgetting about being on top of the ball. But I don't want to, preempt his model. I'm just basically on about the basic geometry of what he's got going on here. He's got 2 different models. Does he not think that we know which one is which is level? Oh, we don't know. What we need is some guy on Discord and some YouTube to make some videos to let us know that water level actually drops away from the horizontal level, which is a different level. But they're both called level and they're different. But then they're the same, but they're not. It's obviously one of these is made up. This one or this one. You can make your own mind up. Whether you want to separate level from level or you want to separate this level from this level. Who knows?
Of course not. He needed content, so he made a straw man saying that the North...
He said, I need content. Listen.
Of course not. He needed content, so he made a calculations or any of my diagrams were wrong. Of course not. He needed content, so he made a straw man saying that the northwest arm was tangent at both ends.
No. Did not need content. We just went over it to prove the difference between straight and curved between the Lake Pontchartrain hump that Blue's just drawn and this straight line. While doing that, we noticed 2 tangents. Paper here was the one that's potted it.
But now he said that we have 2 tangents on the ends. So he rephrased. He's not saying that at the corner station end, but he said that. Can you put it again?
I'll go back here, yeah.
My diagrams were wrong. Of course not. He needed content, so he made a straw man saying that the northwest arm was tangent at both ends. Now, Bev,
Both ends.
Both ends. Where is it? Yeah, here at one end and here at the other. B.
Okay,
Two tangent points.
Okay. I misunderstood because I thought he was saying about two end stations.
No. Two ends of this one arm. Which he has. He's got a tangent point at A and a tangent point at B. He's admitted it. Two tangents. But now he's saying it's a straw man. Listen.
and when Bev reviewed my video, did he show that the elevations, my calculations, or any of my diagrams were wrong? Of course not. He needed content, so he made a straw man saying that the northwest arm was tangent at both ends.
It is. He's admitted it.
Yes, but now this is your straw man.
Yeah, but how can I make a straw man by stating a fact where he's admitted it? He's also admitted it's impossible.
Yes, that's the way that sophists are talking.
Yeah, no doubt some of the Globe Earth gang are going to go along with this guy. He's just slandering me. Saying I'm making straw men out for pointing out facts where he's put tangents on it. It's got tangent points, A and B. I've done a drawing. He's showing the drawing.
Now, Bev likes to call people in the Globe community model afflicted, but...
Yeah. Obviously, for good reason. You should come and listen to some of them talking to us. Obviously, model afflicted.
He is really the one that is afflicted with this model of straight level lines. Now, he's been in this debate for a long time, so you think...
Not debate. This is not a debate. I've not been here in the debate at all. In fact, if anybody's ever heard me, you will have heard me say, there is no debate around here. None. Not at all.
But he also said that you are model afflicted and your model is straight line.
Yeah.
Your model is straight line.
My model is, Euclidean geometry. That's it. Yeah.
I think by now he would understand that on the globe, level lines of different elevations are concentric circles.
Level lines of equal elevations are concentric circles. Said F.E. Dogma.
This is a part that I personally find interesting, let's say. He says that you don't understand that on the globe, which obviously you do understand because that's how you can point out how ridiculous it is.
Yeah. Everything's a circle on the globe.
It sounds like a dogma, but why he's naming himself F.E. Dogma? He should say this is globe dogma, not F.E. Dogma. This is not well.
This is definitely of all of the people, this guy's called F.E. Dogma. And he's done a ridiculous thing. He calls it impossible himself. Put two tangents on a straight line and labelled it horizontal. An impossible task for the glober to achieve anyway, for anybody to achieve. But the globe Earth, crazy task for them to achieve. And then...
and where are the people backing him up? Like now, where are they? Not, I don't know how many are listening in, but there's got to be one or two that can back that up. I mean, who's going to back that up? That picture there.
Well, he's called F.E. Dogma, and yet He's given a ridiculous task for the Globe Gang, and the Globe guys are defending him. He literally is setting the dogma for the Globe guys to follow. Because not one of the Globe guys have gone, yeah, you can't really have two tangents. It is impossible. I don't know what he's doing there. Not one of them have said that. Even Alpha that came in today initially said, yeah, that's fucking stupid. I don't know what he's doing there. But then came back later. He had to accept it. He had to be assimilated into the Globe dogma, or whether it's Flat Earth dogma. I don't know. Don't really know who FE dogma is, but I do know that the Globe Gang, I don't know how the Globe Defenders are, the big Globe Defenders, but the ones that I've seen, every one of them defend FE dogma. Every one of them.
Is it because he comes out with so much shit that no one else understands, and they're just like, oh, like what you said before, you know, the one who comes out with the information that no one understands is the cleverest, or they think they are, and everyone else just stands back and goes, no, I won't touch that. That's beyond me. That
I think there's an anti-Bev movement that you can establish yourself as a hardcore Glober if you just come over here and slander us.
Yeah, well, anyway, I'd like to just say, FE Dogma, if you're listening, take the names off the things, right? You're not representing anyone with those stupid pictures, especially Bev. You know, and it's just like you say, it's a form of it's a misrepresentation, isn't it? And that can't be allowed. So take it down, mate.
Well, I've been doing it for ages.
No, I don't want to call you mate. Take your mate back. I don't want to call you mate. You're obviously an asshole. Sorry about that. If any children are listening.
It's been perpetuated for a long time. They can say whatever they want about us. Even when we just carry on saying really simple stuff. Be careful with this information. Level being horizontal is a bit of a dangerous thing. You don't want to be saying it out in public.
Yeah, but you'd never think that, would you, really? What's dangerous about level and horizontal?
It's just a group of people that get triggered to fuck.
Saying that in public.
Yeah.
For fear of being labelled something you're not. It's can the people listen hear the insanity behind these Globe Defenders? Hope you can.
Well, it's going to be getting worse soon, isn't it? Right.
Yeah.
Carry on.
So again, the concrete slab is tangent to the end station, and since we live on a globe, that'd be a radius of 3,959 miles plus the additional 529.63 feet. But the end station has a higher elevation, which of course means that the radius is larger and there's no geometry.
You're about to say it again.
Did you say the radius?
Yeah, I'll rewind it, but I'll just point out here. He's got a vertical line. He's got a horizontal line. Perpendicular. He's got this horizontal line going over here. And then there's another vertical line. Not perpendicular.
Yeah.
Falsified it. Like, boom, there you go. Sorry, your geometry's fucked.
And this vertical line on the right side is not perpendicular to this tangent line.
Yeah,
Sorry.
it's not perpendicular to that horizontal there. There's something drastically wrong there. You can't just ignore the fact that you have a vertical that isn't perpendicular to a horizontal. You cannot just brush past it and say, well, you don't understand that. That's fucking ridiculous. But hey, here we go.
And remembering the pendulum Mirrors. Not forgetting those.
Oh, well, he did that earlier with the parallel lines and the curving light beams. I don't know.
Tangent to the end station, and since we live on a globe, that'd be a radius of 3,959 miles plus the additional 529.63 feet. But the end station has a higher elevation, which of course means that the radius is larger, and there's no geometry that says that the northwest arm can be tangent to two concentric circles that have different radii.
See, he says it again.
Look at it.
There's no geometry that allows you to have two different tangent points. I mean, they're not tangent points anyway.
But at the same time, when he is talking about that, what appears on the screen? Horizontal line tangent to a corner station.
Yeah, this is a horizontal line. So this is the corner point here. Look at this here.
So while he is talking about that this is impossible, he's doing on the screen what is impossible.
Mm-hmm. So they've got a difference here of angle, right? Now, does anyone know what we call this?
Really, equipotential angle of adjustment.
Yeah, well done. This is commonly known as the equipotential angle of adjustment. The angle between a horizontal line and a horizontal line. It's fantastic. Just think about it for a second. A horizontal line and a horizontal line. You measure the angle between the horizontal line and the horizontal line. That's how you manage to measure the equipotential angle of adjustment.
They always whack horizontal on the tangent. They haven't figured out they don't need the circle.
Literally, this is why I say the Globe Gang is going crazy. The nerve of the guy to write horizontal line and horizontal line and have an angle.
Go and just anyone, go and just type LIGO in and elevation or just anything. You'll just see LIGO, just a right angle, straightest thing in the universe. None of this.
Well,
none of this shit.
You're going out there, right? You're going out there. You've got a tool. You set it up so it establishes a horizontal, right? Then what you want to do is you want to measure the angle to horizontal, the other horizontal, right?
Yeah, get your tangent.
How do you do that? Like where's that angle going to be measured? Because there's only one horizontal and it has no slope. So where's your angle come from? You have to slope the line. Which one of these horizontals has a slope to it? Because that one isn't a real horizontal. This doesn't exist.
That's why he marked it as green and not so distinct, because this is fake horizontal.
Slipped it in. Yeah. Blue one over here.
Surprised you didn't do it in white.
Yeah. Chaikey's asking us in the chat, how can you say the green line is not perpendicular to the right vertical?
Wow.
Because right vertical is not parallel to left vertical.
It's not vertical. Yeah, it's
not right
vertical.
Either. Yeah, not right.
It's just a line over here.
Can we not forget this place has been built Like
Yeah, I
it
know.
exists.
Yeah.
Yeah, it's definitely straight. We got a laser, and I don't know what they've done with that laser, but it goes from one end and back again.
I drive by it all the time. It's straight.
Yeah, we know it's straight. It's definitely straight. It's their understanding that they think that we think it's not straight for some reason. Like crazy thoughts.
Only time I've asked the control room guy if the tube was horizontal, he told me to go to the beach and watch the boat go over the horizon.
Yeah.
Without answering.
You should have
Still haven't got it.
Yeah, you should have asked him to measure that angle between the horizontal and the horizontal. Like, how big's he get? The equipotential angle of adjustment. How big is it? I mean, FE Dogma, that's one for you to do. Let us know the angle between the two horizontals. And then we'll go from there. It requires circles to have more than 360 degrees, this. Very interesting stuff.
So here's a horizontal line tangent at the corner station, and I know that this is really going to mess with Bev and his buddy's head.
He thinks this is going to mess with me and your guys' heads, right? The fact that he draws a horizontal that isn't horizontal.
I like the way that you put globe hypothesis at the top.
Yeah.
And level lines.
So he's suggesting that it will not mess with normal people, only with Bev and with us.
Yeah. He's doing it especially for us. That's what he's saying. This is what I've been saying all along. This sort of stuff only comes around because we talk about it. These guys literally make shit up.
This is new, it's fresh off the press. And these guys now have got to back this shit up, haven't you, Chike? And he's doing it in there, I expect. I haven't looked at what he's saying, but someone said he's...
The whole team do. Everybody's coming out to back FE Dogma with this. FE Dogma is telling you guys, you Globers, what is required of the globe model. Impossibilities. You have to start accepting them. Just push it a little bit further. The globe model requires you to do that.
Shikey says, LOL, obviously it's messing with your heads. It is evident. Can you not understand what we're doing here? Dismantling the crazy.
Yeah.
Yeah? That's what we're doing. That's your model. Nothing to do with us.
The only way to stop yourself from going mad will be to grab a little bit of logic while you can before you're lost into nutsack land. FE Dogma does not need to tell us. They say, well, you'll be surprised because you guys can't explain it. That's why FE Dogma is doing this, I think. Pushing the globe cause. This is the guy that they need.
Seeing how so much shit he gets you to talk about and back up.
Mm-hmm. Showing it on the screen.
The facts.
This horizontal is real. This horizontal is not. This is ridiculous.
And again, we've done it quite often. How do you, you go and give the builder this drawing, do you? And say, straightest thing in the universe. Yeah, any chance you could just copy this? Sorry, paper.
By the way, this green horizontal line is tangent at corner station, and there is elevation between curved level and this 533 etc. foot.
Yeah.
And this is labeled as tangent. You imagine that?
Yeah.
Yeah. On the left-hand side, 52963 feet. Concrete slab equals horizontal line tangent at end station. Then you got 53378. Exactly, yeah. Different measurement on the horizontal tangent.
And then another horizontal at the other end. At a different angle.
Yes, he's repeating what Rumpus did at Blues. He's just repeating that.
But that's what he said was impossible. I think he literally just said it's impossible.
Yes, he did.
Station has a higher elevation, which of course means that the radius is larger, and there's no geometry that says that the northwest arm can be tangent to two concentric circles that have different radii. So here's a horizontal line tangent at the corner station, and
Oh my God.
Yeah.
He literally says there's no geometry that states you can do this, and then goes, I'm going to do it. Literally, just walk straight past it. I'm going to do it. Is that a paralogism, right? Has he noticed that he's literally said it's impossible and then done the impossible? Like, has he realized he's done that?
He's went full on into aporia and walking himself off the cliff. I mean, my God.
Yeah.
This place was built, and I would never have contracted Effie Dogma to build it. Where's the tangent going to be, boys?
You put it anywhere. Doesn't matter. Your quadratic formula won't work, but I mean, who cares? Somebody else will sort it out afterwards. Just fix the numbers. We'll be right.
We do need this to meet in the corner station, but I mean, fuck that.
Just whack a few more mirrors in the corner.
That's where he's put the fucking thing. Like, watch what he does, right? And listen to the words.
That is tangent to the end station, and since we live on a globe, that'd be a radius of 3,959 miles plus
Tangent, because globe, this line.
plus the additional 529.63 feet. But the end station has a higher elevation, which of course means that the radius is larger, and there's no geometry that says that the northwest arm can be tangent to two concentric circles that have different radii.
What?
It's just not possible. There's no geometry that says it's possible for you to have two tangent points on this one line.
Do you think he's doing it on purpose? You know, like trying to catch people out then? Is that...
I think he's doing it for the globers. He's checking the globers. Seriously. Testing whether we can get away with bullshit in the globers. And that's right.
What, do you think he actually is a flat earther?
No. I
Possibly.
think it's Flat Earth Society.
Could be undercover.
All of them are just Flat Earth Society. He's just perpetuating an argument. Because this will now go into an argument of whether that you can have two tangents. They'll separate these lines and say he didn't say that. He didn't say he had two tangents. When, quite clearly, he's just going to draw another fucking tangent here. Watch. He's got a tangent here. This is a horizontal line tangent at the end station. Here.
So here's a horizontal line tangent at the corner station, and I know
It's the horizontal line tangent at the corner station. It's tangent here, and it's tangent here.
In the air.
Literally, yeah. In the air. He's told everybody this is a toothpick tangent. Wally's toothpick tangent. Here it is. He told you it's impossible, then does it anyway. He's got horizontal line and horizontal line with an angle in between them. He's got an impossibility of tangent lines. No.
Can I point something out before you press play next?
Yeah, go on.
You have I Can Science that in the Discord live chat asking about this whole situation, having Wally explain everything to him right now if you want to.
Well, he's coming out tomorrow, isn't he? He's coming. We can have a word with him tomorrow if he'd rather do that. But yeah, I'm not too sure. I Can Science that if you're out there and you want to come and we can talk about it without. I mean, let Wally try and explain it to you, but we will try and go over it tomorrow. if you want. This is geometry night, but I mean, it's free for all tomorrow.
I know that this is really going to mess with Bev and his buddy's head, but I think like other globe deniers, they really have underdeveloped visual spatial skills.
Underdeveloped visual spatial skills, says the guy that's put 2 tangents on one fucking straight line, and he's got 2 horizontals on the same place. Just do it. Got 2 horizontals on in the same picture with an angle between them. And this guy has the nerve to say that you guys have lacking spatial. I mean, it was all right. It was me. Fair enough. I mean, it's just Bev. People talking shit. But now it's anybody that's over here.
Yes, he's just insulting us. So
Yeah.
that we have poor imagination.
Yeah, no, that's what I was gonna say. I don't think he's saying that. I think he's saying that they're taking on imaginometry, something that we took the piss out of.
Really?
Try again, then.
Let's have a listen again.
Larger, and there's no geometry that says that the northwest arm can be tangent to 2 concentric circles that have different radii. So here's a horizontal line tangent at the corner station, and I know that this is really going to mess with Bev and his buddy's head, but I think like other globe deniers, they really have underdeveloped visual spatial skills. Now this is just a 2-dimensional.
Yeah.
Yeah.
We are lacking. We are lacking of spatial geometry. We cannot imagine things in 3D.
You lack the ability to do imaginometry. They can do it.
Well, I mean, like, if they want to come over and explain it, then I'm all up for that. But in saying that, I've listened to 2, 3, 4 years of them trying to explain their stuff. We developed imaginometry around their bullshit. Think we've heard all of it. And they are definitely lacking. And this is taking it to a new level now, though, where they're just sort of blatantly going for anyone.
Yeah, they used to have the 2. They used to draw it out with the 2 tangents crossing in the middle.
Yeah.
Yeah, from one point to another on there. Now look at it.
It's straight. One of them is straight.
Different.
Yeah, because they would used to have one at the middle intersecting at the high spot in the middle.
Yeah.
Yeah, their game has changed. And this is the start of it.
I'd like to just paraphrase or quote Aristotle in the fact where he said that an educated mind can entertain ideas without accepting them. They've accepted this bullshit. We're used, entertain the thoughts and made up imaginometry for them. Just don't accept it. They full on paralogism. That's worse than that.
Hook, line, and sinker.
2 horizontals with an angle in between the 2 horizontals. That's just amazing.
Right, let me get a picture of that. Hold on, bad boy. There, let me just get a screen. I'll show you the boys at work tomorrow.
The globe hypothesis.
yeah. Hold on.
That's what I asked for Kia like the other day. Is like about the pads. Guy walking up going, I mean, I know you wanted 2 horizontals meeting at a corner, but the levels are off. One's going one way, one's going the other. But I mean, works on a globe.
Yeah, this is fantastic.
The globe in your mind. Your mind globe.
Am I all right now? Have you got a screenshot of that? Yeah.
Thank you. Yeah.
Line with the northwest arm. And since the southwest arm is perpendicular to that corner station, it would literally be coming straight.
The southwest arm is perpendicular to the corner station. What?
No, from the other arm.
Yeah, it's perpendicular to
Connotations
the
as a
other
point.
arm.
They get mixed up with these points and
Yeah.
lines.
Southwest arm perpendicular to corner station. No.
Wow.
No, it's perpendicular to the other straight line. But I mean, it's FE Dogma. Maybe this is one of his mistakes that he's put in there that he can later on go back to say that we were attacking him. And, he fixed it at some other later date.
No, I think that is on purpose because we know that we can have in their model, we can have point vertical to a line. So I think this is not accident.
He's trying to push the narrative, right?
Yes.
The point perpendicular. An impossibility in geometry, but gonna be coming into
as well.
Yeah, coming into a globe geometry. This
point vertical.
They're making this geometry right now. No mistakes, Chaiki says. Yeah, we know, Chaiki. We know that this isn't a mistake. We know this is what the globe model dictates. It's not real geometry. It's globe geometry.
You're growing the geometry, you guys. It's new. I mean, where have you seen that shit before, Chaiki? Have you ever seen that? Anyone else presented that to you before? You ever seen anything like that? On the straightest thing in the universe?
Yeah.
Let's not forget it, ASC.
Yeah, well, I wouldn't keep saying the globe straightest thing in the universe because it was Zanuck, the lying twat, that said it.
Oh, I suppose so. Yeah.
Doesn't really count for anything, does it?
No, but most people do think it's straight. And
well, it's definitely straight.
I mean, it's got to be bloody straight.
Yeah, they've paid a lot of money for those guys to do it. Best to be straight.
You wouldn't want a bloody elevation change in it. I know that.
4 foot.
Straight out of the screen
in the middle.
Me. Now, this is the 2D representation of the southwest arm.
The 2D representation of the southwest arm.
Now, since we live on a globe, right, you really need to visualize.
How many times he said
that? He has to say it since we live on a globe.
That this concrete slab is actually tangent to a spherical surface that has a radius of 3,959 miles plus.
Why does he have to keep saying that? Look, he's put a new tangent, a new starting point at the corner station. He's just said it's impossible. Why is he doing it? What does he think he's doing?
He's repeating these things to as mantra.
Yeah. Yeah, he's reciting his Daily Globe recitements.
Plus the additional 533.78 feet. And here I've added the level line elevation of the end station of the northwest arm. Now, is Bev going to have an aha moment and go, hey, I think I finally understand this?
It's got a tangent point at A and a tangent point at fucking B. Holy shit, Dogma.
Well, if you're going to do it, mate, you do it from the same point. Yeah? You don't have it so that it's a step tangent.
Good on you, though, for putting A, B, and C on it. Just to show everyone that you've got a tangent point at A and a tangent point at fucking B. You globe guys have got some genius, right? You all have to defend the twin tangents of LIGO. FE Dogma. The globe requires it. A resetting of this tangent point in a quadratic function. Get used to it.
I would say also that he is trying to separate these two drawings because for some maybe very naive or people, would seem that this B is not same B, because this is BC direction, and on the first drawing is AB direction. It would mean that maybe these are not same tangent lines, because this BC is attached to C and AB is attached to B. So I think this is just childish trick.
Yeah. Yeah, I don't know whether they think it works. I mean, who's it going to work on? If FE Dogma thinks this is going to work on us, like, we'll know, because we actually understand how geometry works. But I think he can fool the Globers. I think he can get quite a lot of Globers to defend this for him. I mean, he's not defending it, is he?
He's not. He's not.
Just doubling down on his stupid fucking video. He's not said anything new. And he's not gone away from anything. He's just said exactly the same thing. He's doubled down on it. He's shown us. He said, yes, there are two tangents. And now at the end of the video, he's showing it again. Two tangents.
Yep. And that's really clear that. I mean, there were times where I was like, I'm trying to get my head around this because my eyesight isn't the best. I couldn't work out, the corner stations. But there, on that one, the way you got it.
I think Jakey might have had a bit of part in this, Jakey. I hope you've really helped out, Jake. If you've...
Well done, Jake.
Yeah, if FE Dogma's come over and said, Jakey, give us some help on this, will you? And you've said, tell you what, go with the two tangents. Just stick with it. You'll be right.
Yeah, they won't notice that you got a fucking 4-foot step in the corner station.
Jakey, come on. Let's hear it, Jakey. What is it that you think I'm fooling myself with?
Yeah, come on.
What is it? He's got a tangent point at B and a tangent point at A. There's a B here. It's the same B. It's ridiculous. Okay, I've got to finish this video anyway.
Nah, I really doubt it. I think he'll just use this to make more content. I mean, let's be honest. How could one ignore the fact that his own model was such a failure and then turn around and make a straw man argument to divert attention away from that truth?
See, he says this is my model. It's fucking not. That's fucking ridiculous. That's not my model. FE Dogma, check with me. If you want to know what my model is, come and fucking ask. Come and have a chat.
He will not do that.
No point in talking to that Chikey. He ain't got a clue.
Yeah, Chikey's obviously helped him out.
Yeah.
So, yeah.
Same B, different tangent line. Curved laser beams. He didn't put Bev on that one, though, did he?
No.
On the title.
No. Let me, I think I need to get this as a... Because he's done it, hasn't he? Mm-hmm. Copy, right. Close that down.
This is your model, he keeps putting. Level is horizontal. Is a straight line, you fool.
The level is horizontal model. Yeah, like traditional mathematics models. The ones that you map elevation profiles on with the X and a Y graph. Those traditional elevation profiles. They're the ones that Chikey thinks are funny.
I mean, the real. Can you see the dim writing? It's got the levels. 535 feet level line. That's a straight line across there, horizontal. Yeah, and the bottom one. There's the bit behind it resembles something of an elevation drawing, but the writing and the curve bits are trying to confuse people there. I think no need for that.
Toothpick tangents for the win. New globe model geometry. I'm liking it. Nobody's been this inventive for ages on the globe side. And think all it took was us watching one video of FE dogmas to point out a bad geometric error. Can you imagine how many other globe mistakes there are out there and what might happen?
Oh, blue marbles.
Yeah, he says shared elevation doesn't necessarily mean a shared point, Bev. The corner point. Don't be an idiot. Those tangent lines are for two different lines, and they're at two different elevations. Are you thick to get it?
No, blue marble. It's you.
Blue, he's got two tangent points, one at A and one at B. And you've got a horizontal line. Have you got a horizontal line that changes elevations, Blue? Do you think it's a horizontal line? With differing elevations at either end. A sloping horizontal. And which way would it slope? Would it slope in different directions depending on which end you're at? Or would it slope down and then up?
Yeah, they haven't got that bit yet.
No, well, I mean, yeah, I don't want to push it too far.
Not yet.
Well, we might have to talk about LIGO a bit. I can science that. We need to go over straight. We need to have an understanding of what straight is. And LIGO is definitely the thing so we can understand what straight is. And I'd just like to go over with I can science that he doesn't actually think that I think straight curves upwards. Or the LIGO arms actually go up 4 foot. I don't think that at all. I think horizontal, level, straight. All the way, both arms. On the X and the Y axis. That would be the easiest way to explain it. If you wanted me to
build that, I reckon I could build it. I know it's, yeah, I reckon I could do that. Level, horizontal. Should have asked me.
Chike's now saying we got it right by saying that there's two tangent line. Chike's getting confused as well.
No, I'll claim, mate.
Yeah.
This is, well, I don't know why he calls himself FE Dogma when he's, well, I don't know, maybe he is or isn't.
He's setting the globe dogma, but I mean, I think it's Flat Earth Society. I think anyone with FE in their name is letting everybody know on the globe side and the Flat Earth side that they're Flat Earth Society. They're going to perpetuate the bullshit argument for as long as they can. Mm. They've got no reason to stop the bullshit.
Most people would have just backed off and just, wouldn't they? Just back off because it's getting a bit hot. But you're going to double down on this shit with all these people, well, a couple of people in here, Blue Marble and Chike, backing him up.
Alika says,
that's all right,
what's this channel about? Yeah. Just a minute. Alika says, what's this channel about? This channel is about logic, geometry, and trying to understand what the fuck's going on. At the minute, we found a video where the Globe Earther, Flat Earth Dogma, sounds great, doesn't it? Did a video where he put a tangent point at each end of one of the arms of LIGO. Then he said it's an impossibility, which we already said. We said the fact that he's done it is an impossibility. That's why we were asking the Globers what to do. Not one of the Globers said it's an impossibility other than FE Dogma. All of the other Globers defended FE Dogma's thing. And we're not reading Discord at the minute. That's just on in the chat.
It's like the
But
Twilight
you can
Zone.
read it if you
For
want.
real.
But when you're grounded,
pictures down.
none of this matters, really, does it? You know, like not.
Twilight Zone.
For them.
Yeah, for them, all we're missing is the music.
FE Dogma is stitched them up.
Chaiki doesn't think he
They
lives
can't see
in
it.
the
You got it right.
Yeah,
you
Chaiki
said
says we
slop.
when it slopes in different directions, depending where you stood. The horizontal
put a
has a
tangent anywhere.
different slope depending on where you are, says
Yeah, what happens if
Chaiki.
you stood in the middle of the arms? What happens then? You get like a tangent both ways. 4 tangents from the center point of the arm.
Yeah, they like to forget that this tangent line is dropping everywhere in every direction, not only in one particular direction to this or that point, because they claim is that this tangent, blues claim is that this tangent point is going down only in one direction, not in every direction. This is silly, just silly. But he's repeating this argument. This is not new.
Yeah, this FE Dogma one it's not a new argument. I've been through it loads on Twitter and all of that, but this is about as public as anybody's ever gone with these things. I can tell you where the argument's going. I've been over it 3, 4, 5 times. It always goes the same way. And it is going as planned. Just waiting to see what who's going to be brave enough to make the next globe move. FE Dogma? I don't think he's up for it. I think we need a new one. FE Dogma's done. He's not coming to talk about this. He's going to leave somebody else to do it for him. Don't know who we're going to have, because I don't know who the next globe geometer is. The ones that were pretending to be surveyors, they've gone.
You don't live on a ball points out that Chaiki is failing to understand basic geometry, which is, evident.
Yes. Yeah, I think pretty soon, I think 2D, 3D, I'd say. That's what's coming next. It always goes like this in a cycle. You go from curved hump water to point out that there is a straight, so you can tell the difference. And then they obfuscate into 2D, 3D. You don't know the difference between 2D, 3D. To obfuscate from the fact that you can actually measure a drop. Like FE Dogma's done in this video tonight. His new video he's done today. There is a measurable drop of the water level from the horizontal on the globe model. Not in reality. You can't do it in reality. But in the globe model, yes, you can measure a drop of the water level in the distance. In reality, we call that flowing water. Water finding its level. But not on the globe model. Like they keep saying to us, we don't understand the globe model. Well, I think we do understand the globe model, and we understand it well enough to say it's a figment of you guys' imagination. There's just nothing provable in reality. There's no geometry.
Sorry, Bev. You just got to be careful when you say understand. I think there's. I mean, I don't even like to say I understand it because I don't stand under it because it's complete and utter horseshit, right? But you can see the reasons why it's ununderstandable. Is that such a word?
Yeah. Well, yeah, through my understanding of geometry, I can see every problem for the globe model. Right? I can see all of the contradictions that people have to hold in order to be able to have that model and keep hold of it. I don't have it. I think that's my ability. I just don't have the model. So therefore, I can see how other people treat things. I can see it objectively. I can stand back, take a step back. In reality, on the elevation graph, the elevation line curved, says Chaiki. And then he's saying, address this paradox. Chaiki knows it's a paradox.
So if he knows that this is paradox, it means that the paradox is solved, because if you point out that something is paradox, you resolved paradox.
Mm-hmm.
So nothing more to say.
Yeah, it cannot happen as depicted. It's a paradox. All you need to do is work out where. I would say level is horizontal. Start there. See whether you end up with the paradox. See whether it's just some numbers that somebody's wrote down that don't actually fit the quadratic formula.
Chaiki's just trolling.
Mm-hmm. Yeah, no, Chaiki's got nothing. Chaiki's never had anything. But the fact that Chaiki's decided to come round tonight may mean that Chaiki's had a little bit of a help with sorting this one out. He's like, you keep doing it, FE Dogma. We'll sort it out. We'll do the gaslighting and the Alice in Wonderland shit just to keep people going. We can do that for you.
Chaiki had a hand in this? No way.
Look what he said. It's a paradox in your model, not on a globe. Dilithiist.
But he just said that this is paradox on his model.
Yeah.
Yeah.
Address this paradox. This isn't this is a paradox on your model. Which model, Chaik? I don't have a paradox. Level is horizontal. The beam is straight and horizontal at the same time. There's no problem.
It's only Thursday, Chaiki. Don't start drinking yet. Tomorrow. Wait, one more day.
Why do he's saying go ahead, plot an elevation graph. It is straight. Chaik. The beam is straight. Plotting an elevation profile won't help. The beam will still be straight. And if you know anything about plans, if the actual thing is straight, the elevation profile will always be straight also. How can they not get this?
Is Chaiki one of these geniuses that thinks the arms are higher at either end and a ball would roll in the middle? Chaiki, are you one of these geniuses?
Straight, imagine. Can anybody else give us an elevation profile of anything else that's ever been built that is a straight line, but the elevation profile isn't straight. Like a building. Maybe a warehouse. That they wanted a concrete pad building that is actually straight. Has anyone ever seen an elevation profile of a straight thing that curves? I'm guessing no.
Negative.
Nobody's ever going to have seen that before. Just for this one thing, LIGO, which is the straightest thing that I think they've ever made. Unless you talk about those tracks. The rocket sled tracks or whatever. They've got to be pretty straight. No humps in those.
I would assume CERN also. What is it, 27 kilometers? Imagine that's pretty straight. I don't know.
Okay then.
I'm just guessing now.
In knowing that nobody ever in the history of man has ever depicted a straight thing in elevation as not straight, what would make somebody actually draw an elevation profile of a straight thing that isn't straight? What could possibly make somebody do that?
Well, they have to imagine Big E and start from there.
They have to have curved level. Without curved level, they couldn't draw that in that way.
I think I'll put blue marble science. Can we have that one? And so we've got Alpha in the chat, and he's saying that Beddy has forgotten everything that he ever knew about logic. I hope he gets better. Oh, fuck. Send him all our best. See whether he can get some logic back again. Right, here we go. Boom. Check that. 2 files. Close that screen off. And move this back over to Discord.
Look at that.
There we go.
I freak when I see that one. Well, both of them, actually.
So we've got Blue Marble Science and his elevation profile with the internal tangent plane, and the elevation profile of LIGO. Both of these things are in Louisiana. Rakia is our man on the spot. He's been over them. Actually, Rakia is one of these guys that would know what an elevation profile looks like, because he has to do concrete pours. Bet he's never seen an elevation profile that is curved for a straight thing. I'm pretty sure that if you were to show that picture to any contractor anywhere, they wouldn't have a clue that that was a horizontal straight line.
Don't forget that other gem that he gave us. The triple horizontal.
Y'all mind if I ask a question real quick, just to kind of clarify? I've been listening for a little while, and I'm just trying to get my mind wrapped around what's being said.
Yeah, go on. Well, we'll try and clarify it.
Well, I'm just trying to imagine this on a smaller scale. So if I take, like, let's just say 2 toothpicks and put them on a basketball, and if y'all are talking like LIGO being a straight line, and the tangent point starting from wherever that's coming from if I just extrapolate that out, the ball goes away from the straight line. So the straight line necessarily has to be straight. Now, I think what the thing is saying that if it wasn't straight, the azimuth of whatever you're looking at would end up being two identical horizontals. But since the end is dropping away and it's at a different azimuth, then your perpendicular from that point creates a new horizontal.
There's no azimuth for this.
Well, from whatever device he's using to measure it.
No, it's LIGO. It's a concrete slab that's already there.
Oh, I thought y'all said somebody had measured it and measured a deviation from it.
No. He's just calculating everything. It is literally. It's just LIGO. So, it's a concrete slab that's already straight.
But would it not? If the LIGO device was meant to be straight, and that was its. And it
is straight.
The Earth was curved. Okay, we know that. But if the Earth was curved underneath it by any degree,
it would be definitely. The Earth goes up and down all over the place.
I understand that, but when we're talking about elevation, we're talking about a distance from a central point on a radius out.
No.
Well, that's the way I understand.
Yeah, you're talking from a distance from mean sea level.
Mean sea level. Yeah. So
that's not a radius, is it? It's not a radius.
No. I'm saying on their model. If that was, then that would be. I can draw an arc, and then just make that my mean sea level, and then elevation above that arc would be, let's just say a foot. So it would remain equal all the way across the arc.
It's a vertical change, so it's on a vertical datum. The elevation change is on the vertical datum. No.
So let's get all that out of the. I'm asking if you put a toothpick on a ball, a toothpick is straight. So if you put one edge, the very tip of the toothpick on a ball, it goes out some distance. That distance will change from the point touching the ball out into free space from the center point of that ball or curve or whatever, circle.
You can't get to the center point of that ball, though, can you?
Yes, but well, I don't care about that. What I'm saying. Well, on a little ball, I
about it.
No. I'm saying just with me and you talking logically. Could I hand you a ball, and we say forget all the math, forget everything. Me and you look at this ball, and we start devising our own units of measure. Say toothpick is our unit of measure. And then we start coming to our own realizations about it, regardless of what we live on.
We're coming to our own realizations of toothpick.
No, we're using, I'm just saying a unit of measure is arbitrary. We apply it. So my unit of measure in this example that I'm giving you on let's say a beach ball would be, the unit of measure would be what me and you both agree on, the length of a toothpick. Now we can take toothpick.
Oh, come on. You've just got a ball and you're toothpicking.
Make perfect sense to you.
What? What should make perfect sense? You with toothpicks.
Well, then let me just ask you: what would it look? How would you define what we're talking about? If I put a straight line out from a ball, just any ball that I hand you, and the point of whatever I use, get toothpick out of your mind. I don't care what you think it is. Whatever
you said
I
toothpick.
Okay, that was an example. You can use whatever you believe to be a straight. You imagine in your mind whatever is perfectly straight. And let's say it is.
But what do you mean by straight?
What I mean by straight is point A and point B, no deviation. Imagine a rope pulled perfectly taut between your two hands. That's what I would imagine as straight.
The shortest distance between those 2 points.
Correct.
Okay.
So you put one point A on the ball, and then you let point B don't go any direction out, right? or curve to the ball. You just let it do it. It's rigid. It cannot move from this straight line. Now, from
do we get any
B,
drawings?
would you not on this ball be farther away from the surface of the ball?
Yeah, you've gone on a straight line.
Okay, so the elevation of the ball is 0. The surface of the elevation of the ball is 0.
No.
No, where this is this is what we're
Yeah,
talking
but no,
about. This
listen, dude. Whoa. Let me just say, you are using the term ball, right? That is a 3-dimensional Euclidean shape known as a sphere.
Because I'm giving you a ball, and me and you are two people on Earth trying to make up our own understanding of this thing.
Yes, so we are coming to an understanding, right? We know that the ball is 3D. We know the ball is 3D.
Correct. Yes, the ball is 3D.
Right.
Correct.
So the elevation of the ball at its highest point will be called the top of the ball, and the elevation of the ball at its lowest point will be called the bottom of the ball.
No, sir.
Yes.
The elevation of the ball depends on the center.
No, it does
not.
Yes.
See, you don't understand.
You can't have a top at the bottom of a ball. That doesn't work. I can't go along with that. I'm sorry.
If I gave you a ball and said move out 1 inch from the surface of this ball,
you didn't say the top, did you?
Calculate it?
You talking? Are you talking elevation? Right, because the elevation of the ball would be measured from the floor to the top, the height, the diameter.
Oh my God. Okay, yes, you'd be correct in that.
Thank you.
Elevation from what? I'm sorry. I think you understand exactly what I'm talking about. The elevation, if we were talking about from the surface of the ball, if the ball, let's say, was a 6-inch radius ball, if we were to add another inch to that radius,
so
then I would be adding
an inch away from the surface.
Correct.
Right. What do you call a straight line that doesn't touch the surface of a sphere?
Sir, I'm just asking so me and you can both agree on if I was to add a rigid object, a rigid, straight, whatever you perceive it as, on a surface of a ball that me and you both agree is a real
You said it was away from the surface of the ball.
No, you put it on the surface. Let the point A touch the surface.
Okay.
Okay? And then it goes out into space. You're looking at it. It's right in front of you.
It's a tangent.
Correct. It would be a tangent from point A.
Would it be an internal tangent?
Would it be a what?
An internal tangent.
Sir, if it were a ball, can you just... Would the...
I've got a picture. Can you see that picture in the chat? I've got one of Blue Marble.
No, I'm actually on my phone.
He has the elevation above the tangent plane.
That's okay. I don't care about his experiment.
But is that the tangent plane you're talking about? The one that Blue Marble's got pictured in his drawing.
I was confused about the terms y'all were using. It seemed as though you were saying that you couldn't have a tangent. You couldn't have two tangents. That wouldn't make any sense. And all I'm saying is it makes sense if you subscribe to a round surface.
No, you can't have two tangents on one straight line. It's impossible. Even F.E. Dogma says that's impossible.
Sir, you can't have two tangents on a straight line. Yeah. But if it was curved, we are no longer talking about straight lines.
But we are talking about LIGO, and it is definitely straight.
That's why I asked you to imagine the toothpick. It is definitely straight.
Okay.
Would the surface
of the ball cannot have two tangents on it then? It's a simple answer.
That's why I was trying to get with so we can have an agreement. Then I want to know what you would call it. So on this ball with this toothpick sticking out into space, when the ball...
Are we still with LIGO?
Yes.
So
Correct?
you're using a ball and a toothpick to explain LIGO.
Do you have an issue with analogies?
No, I'd love to see it. Can we get a video or a drawing or something of you? I'm not a very good imaginative guy. I would love to see a picture of it or something. A drawing?
Yeah.
Can you do that?
Literally, you draw an art.
Can you draw it for us? Let's have a look.
Can.
Yeah.
This is very contentious. This is very odd.
What?
If me and you can both have a understanding of what I'm talking about.
Well, let's have a look at it, and we might be able to come to an understanding.
I'm sitting in my backyard enjoying nature. I can't sit here and but all I need is okay. Are you going to purposely not try to understand what I'm saying? It's because that seems like what it's doing.
But I would like to say that you're talking about LIGO, balls, and
correct.
Toothpicks.
Is LIGO? Well, that's what I was saying. We both said LIGO was a straight
definitely
line, correct.
Well, it's like perpendicular. It's two straight arms.
Perpendicular straight lines.
Yeah.
Coming to a point, and each one of them goes 90 degrees out from each other, 4 kilometers. Correct?
Yeah. That's LIGO, the concrete pads.
So if it was flat, I agree. Parallel lines, equal horizontals, yada yada yada.
So they are. We are agreeing now, right? That these two arms perpendicular and they are horizontal, right?
I didn't hear what you said.
Oh, well, these two arms are they straight, perpendicular, and horizontal? Can we just so I can get an idea what we're talking about?
They're straight, perpendicular, and horizontal from point A.
Just horizontal. They are horizontal then. Good.
Horizontal with reference to one point.
Yeah, like a benchmark.
Wherever they first decided to set it up, they put a plumb bob or whatever kind of instrument they use to measure vertical and horizontal at that point.
Well, no, they would have found an established benchmark and then transferred that over. So that would be the starting point there, yeah.
Okay.
Right.
However,
yeah.
Yes. So from that point, they would move out however many feet, yards, whatever. We can call it the 4 kilometers. They move out that much.
Yeah.
If the elevation is from mean sea level, and mean sea level on a flat plane is just whatever y'all say it is. It's just flat, or it's whatever Globers say it elevation is, and it's round. Mean sea level would be an even distance from the center of the Earth.
Yeah.
If that's the case,
what?
We can. I thought you understood the globe model.
Yeah, but how do you, not wanting to be picky or anything, but how do you measure from mean sea level to center? Or do you just take that as a given number?
I don't know. So this whole thing started with me trying to understand where your geometry was coming from. I don't know.
My geometry is Euclidean geometry. That's dead easy for you to understand that, mate.
A ball goes away from a straight line if it's a rigid line in space. And you're acting like that doesn't happen. And me and you both know that happens. Everybody on the planet knows that happens.
Knows that what happens? A tangent.
Yes, that you have a rigid line in space, put it on a ball, the rest of the ball falls away from the tangent line.
Wow.
And then if you can create another tangent line 4 kilometers away or whatever on that circumference, that percentage of that circumference, then you're going to establish a new tangent from that point because you have a new center or a new down angle.
Yeah, it sounds like you're just trying to make up stuff as you're going along here with this geometry business. Have you ever looked at Euclidean geometry?
Yes, I know all about Euclid. I also know about spherical geometry, which it seems as though y'all are ignoring.
Interested. That's good. You know that.
Excess?
Yeah.
How does that happen?
Do you know that there
Me
are?
and you. See, that's another thing. Me and you can both agree on what Euclid stated.
Okay.
Those all are true.
Okay.
But when we start discussing,
since you know spherical geometry, you would know that there's no such thing as a tangent in spherical geometry, wouldn't you?
There is what we can describe.
Not a tangent in spherical geometry, no. Tangents are Euclidean geometry only, not spherical.
And what? I don't. So when we try to describe something, that's why I was trying to get you away from using this verbiage, because me and you could both sit down and we could draw a circle and we can both use our minds and understand the difference between 2D,
Did you put
3D.
Draw a circle first? Did you say we could both sit down, draw a circle, and use our minds?
A line, we could draw a circle. Look, I could take a triangle, and me and you could both be like, huh, that's crazy, all of it 180 degrees. And then we could take that same triangle and put it on a ball, and be like, whoa, that's crazy. So if I've got excess in a triangle, that must tell me something about the surface.
You got excess. Excess
if
what?
I have excess in the angles that come together.
No, the triangles only have 180. Triangles only have 180.
I believe all the postulates, all that stuff. If what you're stating is because we find spherical excess, it must be true then that the surface is not flat. And I know what you say. Oh, I never say it's flat. I never, but
no, like, dude, whoa, slow down, because you're imagining that I'm saying things that I've never said. Triangles only have 180 degrees. They don't miraculously get any extra ones anywhere.
It no longer, see, that's the case. You're totally correct.
Wow.
Can I hold you? Can I please?
Who is this man
Mr.
wise in the ways of geometry?
But the shape does not cease to be a three-sided shape.
What doesn't seem to be a triangle is a three-sided shape, dude.
Exactly.
Yeah, odds.
So if we measure excess in the angle,
is my microphone coming through? Can you hear me?
I can hear you.
Yes, we can hear.
Mr. Odds. Yes, sir. Yeah. You said we can sit down and look at the triangle. Ooh, amazing. 180 degrees. And then you said we can put that same triangle on the ball.
Yes.
That's wrong. No. Listen. Hey.
I agree.
Hey, hello. Yeah. You said that. And that is impossible. That's an impossible thing because obviously a sphere is curved while a triangle has straight lines. So
there is a fundamental difference in the way that y'all, or it seems to me as because I can imagine it perfectly. I don't know why y'all.
It's not a triangle.
It's not.
It wouldn't be.
In first place, this is not the same triangle. This is not the same triangle. You said that we can put same triangle on the sphere.
Okay, the way y'all are picking my words apart, I have to be very careful.
Yes.
Let me preface that with I misspoke.
Yes, be very precise with your words, please.
This is ridiculous. This is a crazy conversation. If I took a triangle that was 60, 60, 60, and I was to take the triangle by leaving the sides
where are you going
rigid, it would become and deform it. Let me tell you. Okay, take a balloon, draw a triangle on it.
Whoa! You're going scatter all over the place. Can we?
I'm just trying to make it. It seems like I gotta do this like y'all are children.
You're blowing balloons up, dude. Slow down.
The triangle transforms. It deforms. It's not a triangle in Euclidean space, but the deformation tells us something about the
What do you mean Euclidean space?
You brought it up, but
where is Euclidean space? Where is that?
Nowhere. It's ideas that me and you could have come up with.
It's triangles that have 180 degrees.
Oh my God. True.
Circles are 2D.
So since we know that.
Squares.
Since we know that.
2D shapes.
If I was to take that triangle and quantify it, put it on something, a transformation happens, and that something had a radius.
A transformation to a radius? A triangle? Is it just transformed into a radius?
Oh my God. If I was to take a triangle, let's say it's made out of string, and put it on a ball, a transformation happens. The thing I'm putting on the ball still has 3 sides.
Like a butterfly type.
But now we measure spherical excess. Because each arm of each leg of that triangle is a great circle.
But yeah, you have not got an angle then.
You can measure an angle.
You can't. Not with curved lines. You can't. You need straight lines.
God.
Yeah.
You can zoom in on the vertex so you get a relatively good. If we're talking about like into infinities, you're exactly
relatively.
Right.
Yeah.
Did you just say zoom into a vertex?
Yeah, he did.
Yes, until you can get a quantifier.
And relatively.
I could have cut in so many other times, but that was the doozy.
Yeah, that's good.
We're talking about error.
Let him go.
Listen
to him.
If I
He's
can
keen.
do this, and if I can give this to a friend around the world, and I can take a triangle and just tell him how much spherical excess I have, and then he can 3D print that same
extra
Oh, go on, please. Get him to
Then
3D print a
work?
triangle with extra
How
more
does
than
that
180 degrees. Never even thought of that before.
It's because of the more than 180 degrees that we know it's no longer a flat plane.
A 3D printed triangle with more than 180 degrees.
Works, dude. You can try to like go around it all you want, smith your way through this.
You
but
just ignored all the things that were pointed out to you. It's illogical and absurd geometrically.
Now you're talking through people.
He's
just
keen.
Like every other Clover I've ever heard.
He's keen, though. Listen to his enthusiasm. He knows this is the time where they're making up shit. Literally. This is where the globe is made up.
I can't do anything. I don't have any measurements.
He's got his history. He's marking his name in history.
Wait, can I then ask, if you have no measurements, why do you believe it's possible to have triangles with more than 180
the whole
degrees?
Point is, y'all literally said you can't have a straight line coming off without an elevation difference. That's totally wrong. If it's a ball, you can. That's all I was saying.
I don't think you're saying anything. It's saying too fast. Can you just, please try and slow down a bit, so at least somebody might be able to come along with you on your journey?
What would you like me to
pull a big string, lay it over your curved surface of water, and show us that string curving? Maybe measure it even. That's a thought.
Can't do that. That's a straw man.
Oh,
Nobody
you can't do it.
That.
It's just a fantasy model that you brought up to us, saying you're laying a string over a ball. Piss off.
You can do that. A ball in your backyard. Can you not do that?
Yeah, it's Euclidean 3D.
Yeah.
Okay.
Solid geometry.
Yeah, look up spherical geometry. They tell you exactly how to
compute all Euclidean, dude. Euclidean ball in your back garden.
Oh
Euclidean.
Then okay.
Mm-hmm.
Cool. So me and you can both, regardless of the terms we use, can we both agree that if a triangle deforms in a way, and it's no longer a triangle, that if it shows the angles being more than 60, can we now use that information?
It's not a triangle. They're not angles.
It won't be a triangle.
I know, but you don't understand. You don't understand Euclidean geometry, obviously.
I don't care about Euclid and Euclidean geometry. You keep going back to that because you get people stuck in a wall.
You asked him what geometry that he's using. You just asked that like 10 minutes ago, and now you're saying you don't care what geometry he's talking about.
My point
because it's inconvenient.
Me and him can both sit in the backyard.
Did you just hear what I said?
It doesn't matter what the terms are.
Listen to me. Repeat what I'm going to say.
It doesn't matter what the terms are.
Wow.
Yeah, you just asked him what geometry he was using and talking about, and now 10 minutes later, in the past tense, you're saying it doesn't matter what geometry you're using. Terms don't matter.
If me, okay, let me ask you, if me and you were to sit in a backyard and we were to, how do you think these guys, y'all think y'all are the first people in history to think this stuff up?
You think you're the first person in history to be deceived by
These are
mathematics?
questions that have been asked over and over and over again.
You're talking about strings being laid down on the surface of the earth. And you're talking about us being fools?
No, on a ball in your backyard.
Yeah, but you made it relative to the earth. Yeah, no, because you can't do it. The earth is not a ball. Do you get it?
No, can we just not do this, right? You're trying to explain this model of yours, but you keep taking us to a ball in your back garden.
I would adopt any model.
We're talking about LIGO.
That's what I was trying.
Why do you keep putting a fucking toothpick on a basketball?
Okay, let's talk about LIGO. If LIGO comes out 4 kilometers on a ball, that's whatever the 3,000.
Forget about the ball. Forget about the ball.
He did it again. First sentence.
I'm saying if it was flat, we all know that it would be equal and all that, and the elevation wouldn't change.
It is straight and perpendicular. That's what it is.
You said the gentleman measured a elevation change, and how could that be?
I didn't say they've measured. No, I did not say they've measured an elevation change. I'm not looking at what you're looking at. Straight. That's it.
But whatever they measured, you said there was a elevation change below.
No, FE Dogma. FE Dogma said some numbers or something. All we know is one arm is horizontal. The other arm meets it at the corner point, is also horizontal, and they are both perpendicular.
Okay, and all I want to know that is only if, this is just so I can see where your mind's at. If it was round beneath it, would you expect the ground to get farther away as that straight line progressed into free space? Would you expect
if there was a ball underneath it and it was like a right angle, then the ball would move away. Right now, no, wait a minute, whoa. Now, if it was like that, could you have 2 tangent points? One at A, at one arm, one end of it, and then another tangent point at the corner section. Could you possibly do that?
I would have one tangent at A that went all the way down that would do what me and you both described, the ball moving away from it.
In fact, have we got a picture of Wally? Can you see the chat? Can we get Wally's thing?
If I was to measure a new point, a distance away from point A, a new tangent could be created at that point from reference to B, because now we have a new reference to down.
Do you know what a tangent is?
Yes.
Yeah. Can you see this in the chat, in the live chat?
I'm not on my hand.
Go on, jump in live chat.
Yes.
Now, that's Wally.
Okay.
Do you know Wally?
Yeah. No.
Oh, right. That's Wally.
No clue who this guy is.
Well, it's Wally.
Looks like Waldo.
Yeah, it's Wally.
Okay.
Right. So he's got a tangent point, like you just said.
Yeah, he's got a 3, 4, 5. What is that? Square on a ball.
Yeah.
Yeah. Okay.
Right. So B.
Yeah.
How do you develop a tangent at B? Because that's what FE Dogma set you challenge. 2 tangents.
My eyes aren't real. Okay, hang on. My eyes aren't real good. So B would be 90 degrees from the tangent set. Perpendicular to B would be 90 degrees from the tangent set at A. And then at the pink dot where B touches the surface, that surface, now I can create a new tangent point.
B doesn't touch the surface though, does it?
No, whatever he drops down. See that line?
Yeah. Toothpick tangent.
It's an imaginary.
Yeah, it's a toothpick tangent.
Yeah, so
it's inventive, isn't it?
So listen. A goes the tangent or the perpendicular of A goes to the center of that ball. Correct?
If that's the tangent, yeah, that line AB becomes the tangent to the ball.
Just rotate on the center.
What?
Out towards B, where B would be, and then straight out from the center to infinity. You can make any new tangent point off that.
Well, no, a tangent point should be touching the ball, shouldn't it? Isn't it where a straight line touches the ball? That's why we said the initial line, AB, it's impossible to put any more tangents on it because you can only have one tangent point on a straight line.
Correct, on a straight line. You're correct about that.
Right, so FE Dogma put another tangent point at B. How is that possible?
So now I'm getting more clear on what you're saying. If he was to break reference frame and create a new reference, the difference between the two tangents, if you knew enough, you could work out the arc, and especially if you had the distance between the two and figure out radius with that.
Yeah, but how would you get a tangent there? Because you know what a tangent is, right?
The tangent is perpendicular to whatever you think is down at whatever point you're at.
No, a tangent is the point that a straight line touches a circle or a curve.
Yes, and okay.
So B, it's impossible for B to touch the surface, isn't it? Because it's part of a straight line that already has a point that's touching the surface.
But if you were to build a stand under B,
like a toothpick tangent, toothpick tangent.
No, you would have to support it. So you would have to make that stand longer than the one before it, and the one before that you'd have to use a more say it's concrete. You'd have to use a more volume of concrete.
Yeah, that's a toothpick tangent. Yeah. I thought when Wally did that, it was absolutely genius. Yeah.
I liked it. I liked the toothpick tangent. I thought you could understand it.
I can definitely understand the toothpick tangent.
But okay, so it gets longer as you get away. I mean, I thought y'all were saying that didn't happen. That's all I thought. I was just trying to get clarity on what the deal was with the things can't move away from a curved line, because we know LIGO's straight. And if it is curved, then the elevation would necessarily have to change. If it's not curved, then whoever the guy is that you're talking about,
what,
not Waldo, who's this other guy?
That's Where's Wally. Where's Wally? Have you ever heard of the Wolf Pack?
I have no idea what you're talking about.
You've never heard of the Wolf Pack?
No.
Oh man.
Wolf Pack. What is this?
What's the Wolf Pack?
You may want to become part of it.
Dude. No, he can't become part of it. He's not Australian.
Thing. I don't even know what y'all. I'm gonna have to go back. I watched the last 3 days of your whatever this is. What it's like, and I saw your link.
Yeah.
And I was like, all right. I just wanted to know literally what y'all were. It seemed like you were saying you couldn't have an additional perpendicular off of a curve. Whenever I can set,
you can't have a perpendicular. You can't have a perpendicular off a curve.
You know what I'm saying? I don't. In the reference of this guy, LIGO, whatever the thing.
I don't think you know what. Something triggered you. Obviously, you came in, and I don't think you really you got what the argument was. It takes a little bit. Yeah, it takes a bit for you to get into this.
You said that the what the reason why I came in is. Yeah, we're talking about the elevation, and the elevation would not go down if it was a straight line coming out. And I said, I was thinking about it, and I was like, if elevation is a point from the center of a ball, and then you just add whatever, then it necessarily has to come down as you move away from the point that it touches A, whatever that A is. And maybe I confused what you were saying. If you're saying that can't happen, then I'm like, what? I'm trying to figure out why that can't happen. And if it does happen,
Euclidean
then I don't know
geometry.
what the other guy's talking about.
If I ever say something is impossible, it's because I've run it through the process of Euclidean geometry and outright ruled it as a reductio ad absurdum or something. It's just impossible.
That,
have you
maybe the verbiage that people are talking about is maybe not the correct verbiage. And that's why I was going to say, if we were sitting in my backyard with just then it's obvious that the thing drops from all around. Obvious.
I think your confusion lays with what you've just said about elevation. It's got nothing to do with the center of a ball whatsoever. That's why there is so much confusion when you come in and just want to talk about the ball all the time, because there is no ball.
This is the first time I've ever done this, so I don't do nothing.
Yeah.
No, but I'm just saying, in reality, right? In actual reality, where we all live, elevation has nothing to do with.
So this is where I think this is where the confusion. I'm talking about a shape, a sphere.
Yeah, I know.
Not the Earth.
But when you bring up elevation and relate the measurement, hold on.
Okay.
When you talk about elevation and then link elevation measurements to the center of a ball, that's not what is actually done in reality.
Okay,
that's not how elevation is measured in reality. So I think that's where the confusion lays.
Maybe this will bridge a gap for you. When I think of elevation, what I'm applying it to is if we have a radius, just add whatever out.
I know, that's what I just said.
Toothpick tangent.
You're increasing the radius.
We can solidify
so
this.
All I'm stating is on this imaginary ball, if whatever y'all are talking about, if you were to increase elevation from whatever the mean is, make the mean your radius. And then elevation is increased from that mean a foot. Then it's just moving up at all points from that.
What are you talking about, man?
Wait, elevation is. I was just.
Yeah, we know your story.
I was just trying to clarify how I thought about it.
Do you ever just listen?
You can't,
dude. I was saying something.
Yeah, we heard you saying blah 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 about mean level of a radius of a ball.
He was trying
That's not even how it's done.
He was trying to work it out, though. He was trying his best to try and work it out live.
Look, that's cool.
You know, elevation isn't done that way, right? You know, elevation isn't done that way, even in your model. You know that, right?
He doesn't.
Dude,
would you like to know how elevation is done?
I'm not talking about Earth. I was talking about just a shape. That's all I was talking about.
Yep.
That's all I was talking about. Y'all keep going back to Earth. Seems like y'all got an issue with this whole Earth thing. I heard this shit about shapes, and I was like, well, that's fucking wrong.
Okay.
So
you want to measure the elevation of a circle, do you? Of a ball?
No, I don't like talking to.
No, okay.
Okay.
Yeah. See you later.
No, you hear me? There?
Yeah, just so you guys know.
Here we go. Go on.
And,
so let's challenge your geometric.
Wait a minute. I was listening to Turn Up, Jake. All right, you can come with your challenge in a minute. Like, what was that, Turn Up?
Well, I was just gonna say I've been listening for a little bit, and you guys all know my level of intellect in here, and even I couldn't understand what the fuck he was trying to say.
Well, he was trying, right? It does get confusing, right? Listening to us here, it's like a new thing.
I was trying to follow. I just couldn't follow. I was trying to understand it was like John. Hey, I want to know what you're saying, John. Just break it down a little bit. That's all.
Okay, Chaiki, challenge on. Let's go.
Yeah, I come even with a drawing.
Nice.
So you see the certain center circle, which from the center of the center circle, there is a line coming up. You agree that the line that crosses it at 90 degrees is a tangent to that circle.
I wouldn't know. It doesn't even look like it's in the center. That to me.
Suppose it's in the center, and suppose it's 90 degrees. I didn't
What do you mean?
measure.
Just suppose.
It's an illustration, Bev. You don't need the right angles there.
Yeah, well, you'd have to come with some words then. Go on. What?
Well, the words are line that come out from the center
of what?
Intersect of the little circle. Intersect that circle, and another line that touch the circle as is 90 degrees to that line that comes from the center is a tangent.
Where's the tangent? On what? This little one?
The red line touches the small circle. That's the tangent.
Okay, perpendicular to that, the radius.
To the vertical line.
It's not vertical. We're just talking about circles now, are we? They were like a radius.
Not vertical. It's gone from down to up. It's not vertical.
Oh, you're talking about on the page to signify it. The purple line that is going up and down the page.
From the center of the small circle.
Yeah. There's a purple line, one that goes off sideways and one that goes up and down. Which one of the two lines are we talking about?
The one that goes up.
Up and down. Okay. And then you've got a perpendicular to that at the point that touches the circle.
Right.
Okay.
That's a tangent.
Okay.
So we have a tangent point on that horizontal line.
Horizontal line?
Well, if that's vertical, the other is horizontal, right? Don't start with the words now.
But it's not vertical. It was just going up and down from side to side, and the one that's going up and down.
What do you mean?
It's
up
perpendicular.
Down, it's vertical now.
Well, it was going up and down before.
The purple line goes up and down.
Yeah.
It's vertical.
And it has a perpendicular one too.
The tangent line
is
horizontal. The red line. Red lines are horizontal. Are tangents. Purple line are, let's call them, I don't know, radius lines. Okay. Okay. So, and that horizontal line also intersects somewhere the concentric circle, the big one.
Yeah.
Right. So we have a shared point between the tangent and the circle up and the big circle, right? Now we connect that point from the center of the concentric circles to where the horizontal line, which is tangent to the other one, intersect the big circle. Right?
Yeah.
And
it would have helped if you'd have put these lines, labeled these lines and points. It would have helped.
And we draw the vertical tangent line, which is 90 degrees, to that purple line, which is also tangent to the big circle. And it intersects the other tangent line. So we have a point on one tangent line, which is not tangent on that line to the other circle, but another line that crosses that point is tangent to this circle. So that's geometrically perfectly possible. I didn't look at the LIGO blueprints. I don't know if it is horizontal or not. I don't care. In principle, it can be.
Well, I hope that made sense to you, Chaiki, because I haven't got a fucking clue what you were talking about. You would have been better labeling these lines and stuff. What was the idea? What was it that you were getting to? What was it a proof for this?
That you can have on the same line two tangent points, which one of them is where another tangent is crossing, not the same line, just like Effie Dogma tell you. One line has one tangent, not possible to have another tangent on that line to any concentric circle. However,
so which one are you saying is LIGO arm there? Which one is LIGO arm A, and then B, and then C, and then like where is the bit that you sort of equate into for
you have
FE
two
Dogma
tangent lines.
Yeah, go on. Put A, B, and C on it somewhere, then we can have a bit more of a clue.
You have two tangent lines.
Go on. A, B, and C. Go on.
Go
on, Chaiki. Come on.
Points. Which one of them is not tangent on that line?
Go on. Label it up for us. A, B, and C. And then we'll see where you've got your tangent point at A and your tangent point at B. Like FE Dogma has told you that you should be doing.
He didn't tell me.
Did he not?
He didn't tell me I need to do anything.
What do you think of Wally's toothpick tangent?
Great.
It's got legs, hasn't it?
Yeah.
You've got to get a tangent somehow. And since it's impossible, you may as well just invent a toothpick tangent. I think it's genius. I'm going to put it in Imaginometry somehow. I'm just working out how to do it. Definitely.
Chaik, you have only one tangent point on that red horizontal line. So, and the claim of the FE Dogma was that there are two on the same line. I cannot see second tangent point at this red line, horizontal line.
Hold your horses. Hold your horses. I know it's difficult for you. Even though it's there, you can see it if I don't put A, B, and C on that line. Okay?
Yeah, go on then. You put A, B, and C on it.
The claim was that the same line, or in your instance, it is this red horizontal line. This line has to have two tangent points. I cannot see this. I cannot see only one point, tangent point, on this small circle. This is the only one tangent point here in this drawing. There is no other here.
There you go.
So there is only one, and you seemed to be eager to prove that there are two. There are not. There is only one on this red horizontal line. Sorry.
You go in there. I've just put a picture in there. LIGO Revisited. That's FE Dogma's thing. He's got a tangent point at A and a tangent point at B, quite clearly. It's got two tangent points.
I think that Chaik doesn't understand FE Dogma claim yet.
Mm-hmm. Yeah. It's a genius challenge.
Now you can see the points where A, B, and C are? Huh? And tell me that
not in your picture, no. A, B, and C in FE Dogma's picture. I've got it on screen now.
B is not on AB.
Where have you labelled yours? Have you?
Oh, I did label.
Okay. So A, B, and C. So you've got a tangent point at A. So that's where FE Dogma's got his tangent point at A. A little circle. And B.
Right. And B, I got another tangent, right? And
nice.
B is laid on AB. So I have two tangent points.
Small circle, big circle. Yeah, that's what we did.
Right.
Yeah, you can just draw a circle anywhere, can't you?
So there's no problem geometrically for FE Dogma's claim.
Yeah, it just has two different circles.
Yes,
right. It does. One at 529 feet, and the other.
You've got a little tiny circle.
doesn't matter, Ben.
Yes, it
Does
does.
it matter? No, it doesn't.
Yeah, you've got a little tiny circle.
Absolutely. As long as
Is that what F.E. Dogma did? Just put a little tiny circle? They put like a rubber ball there at one end.
Yes.
Genius. Yeah, I said that's brilliant.
But
do you not feel a bit sorry for Wally making up toothpick tangents when he could have just put a ball there?
He did show you a tangent at the concentric circle that it is 529 feet elevation, and the other one was at 533 feet elevation.
Yeah, that's the one. Wait a minute, I've got
circle.
that. I get that for you.
But Chaik, what you did is two different lines having two different tangent points on two different circles.
No,
so this this is what you drawn. Two different lines. One horizontal line is tangent to this small circle, and the other line, the other red line, which can be labeled as vertical here, is tangent to big circle. Two lines, two circles, one tangent line. Yes, per circle.
Absolutely right.
Chaiki, can I just quote you? I quote you F.E. Dogma, right? He says, F.E. Dogma says, geometrically impossible for a line to be tangent to two concentric circles with different radii.
Absolutely right, and I don't have.
But isn't that what you said? You could have two
tangent to two concentric circles. Do I have two lines? Each one of them is tangent.
You have 2 points
to a different circle.
No, you have a point at A that is a tangent point, and a point at B that is a tangent point.
Right. And
right.
Point B.
And he says it's geometrically impossible for a line to be tangent to two concentric circles with different radii.
He keeps telling you, AB is not tangent at B.
No, AB is the line. There is a tangent point at A and a tangent point at B.
Yeah.
So like AB is the line, and there is two tangent points on it. One at A, one at B.
Correct. My picture also have two tangent points on AB, one at A and one at B. Only B is not where AB is tangent to the circle, but where BC is tangent to the circle.
Yeah, I'll read it again. I'll read it again. Geometrically impossible for a line to be tangent to two concentric circles with different radii.
Absolutely correct. And my line, each line has only one tangent, not two, just one tangent for each of the lines.
For AB, for the line AB.
You can pick whichever you want.
Yes, but the claim was that it would be the same line. You missed that. You missed
that's
that.
A lie.
Missed that.
That's a blatant lie.
You missed that. You just didn't hear that.
Never missed it, because in the original argument, your original where you have.
We just pointed out that he got two tangent points on the same line. The same thing. We just keep saying the same thing.
Yeah, he has a tangent point on BA at 533, and he has a tangent point on AB at 529. Two different lines. Doesn't matter how many times you repeat it. I'm not going to change my words.
It says geometrically. F.E. Dogma says geometrically impossible.
And I said I agree. I don't have two tangent points of the same line, two different concentric circle. It's two different lines that are tangent.
Yes, that's why your drawing is pointless, completely pointless.
It's not pointless.
Yes, it is pointless because the claim was that the the tangent points, two tangent points on the same line, on the same line.
No.
Yes.
No, no.
Yes.
No. Listen, I also have two tangent points
AB is
on
a
the
line.
same line.
AB is a line,
No,
right?
two different lines, two different circles, two different lines.
Wait. Is point B not on the line AB?
Chaiki.
Do you deny that?
This
point
is your
B
geometry
in
night,
my
right? This
drawing,
is
my
Euclid night.
geometry, right?
Yeah.
Right, Euclid. We're in Euclid.
Yeah.
Is the point B that is on line AB not on line AB? That point which is tangent of the line BC is not on the line AB?
Oh, come on, Chaiki. You're not equipped for
No.
this fucking shit.
They're not equipped.
Yes, you definitely are not equipped for this conversation.
Say to that? I showed you. You can have two tangent points on the same line.
But it's impossible.
One of them is not the tangent point of that line.
If you just draw another circle, you can get away with it dead easy. You can just draw infinite circles wherever you want.
Right.
Right.
How many times we need to repeat it? Point B is tangent for BC.
Yeah.
Point
it's okay.
A
We know. We
AB.
know that FE Dogma is literally just drawing tangent points wherever he wants. He's drawing impossibilities. He is.
I showed you it's possible.
That's why. No, it's not possible. It's an impossibility.
What did I draw wrong?
Well, you drew a little tiny circle at A.
So what?
Well, that shows that it's not what FE Dogma was drawing. Isn't it? It does show that you are trying to misrepresent FE Dogma's drawing in order to justify an impossibility that he's drawn into his original video.
What do you prefer? That we draw very, very large circles with very small gap between them that you wouldn't be able to see anything?
I would prefer if you actually look at geometry and come up with something. No, it looks like a crayon drawing that Jose's done.
It is. But tell me what's wrong with it. Yeah, but don't attach
it's not
the drawing,
like use GeoGebra at least or something like that, right?
No.
Yeah, you would go quite well.
Don't need to. When you go and draw something on your whiteboard, do I tell you, no, this line is not straight? We understand the principle, right? You want me to measure angles now? What's wrong with you?
Well, I'd like to do perpendicular, right? Because that's what you do. In order to find...
I did.
Right. So why do you use a tangent then? What's the use of a tangent?
You wanted the tangent.
Yeah, but what is... No.
On the line
FE Dogma drew a tangent point at A and a tangent point at B.
Yeah, but for different lines. Again,
what is the point in a tangent point? What purpose does it serve? Why is it that you need that?
Like I said, I didn't say you need it. I didn't say that's how it is. I said it's not impossible that it is.
It is impossible. You cannot have two tangent points on the same straight line.
But I showed you it's not. FE Dogma showed you it's not when he told you this is going to blow your mind or something, because you don't get it. You have a different.
He had two horizontals. Line. He had two horizontals.
Two verticals. Right?
He had two horizontals. Let me see.
What can you do? You live on a sphere. Every vertical is different. Now, why don't you address the data? We have 529 feet and 533. And if you follow, if it was a straight line, you would see it on your graph that has a straight baseline. You would see it as a straight line. Doesn't matter how steep it would be, it would never be curved. So why does the line curve when you draw it on the graph, which has straight baseline?
Like, did you see the drawing which Ephidogma drawn in his film with tangent points?
Yes. I addressed it.
And as you can see, there is this is tangent to curve called in this drawing as labeled as curved level. Yes.
And what? I'm trying to find it. Hold on.
There you go. I've put a picture in there for you. It's got two horizontal lines and then an angle. What we're going to call that angle A. I've marked it A.
The elevation angle?
Between a horizontal and a horizontal. Is that the horizontal elevation angle?
No, between point B and point C.
No, we've got a horizontal line as your baseline, and then you're measuring the angle up to the horizontal line, right? So it's the angle between the two horizontals. What should we call that? It's got to have a very special name, that.
No, what you talking about? You have elevation from 529 to 533, and then you have from 533 to what? I don't know.
Whatever. We have a level line, and this is curved line. So
which line is curved? The level line is curved, right?
Yes, in this drawing, yes.
It results in an angle between two horizontals, like you curving the level line has repercussions.
Yes,
right.
And this consequence is that this curved level line, it is supposedly Earth curve. So you cannot have two different Earth curves on the same globe. And in your drawing, you drew two circles or two globe Earths. So it doesn't match what Ephidogma drawn.
No. There is a curved elevation line at 529, which is 529 bigger. It's bigger in radius than the Earth mean sea level, and the line above it is the curve of the line at 533 elevation. There are no real spheres. Those are elevation lines.
The sphere's not real, did you just say?
What do you mean the sphere is not? Mean sea level is curved, pretty curved like this.
Yeah, but you just said that the spheres aren't real. They're not there.
Spheres, yes. One is, like you say, down mountains. But if we go to elevation 533 and we mark all points in the air, 533, it will form a curved line.
No, it won't.
Yeah. Want to bet?
Yeah. Hey, but this is not Earth surface, so it cannot be a tangent point.
Equal elevation is a horizontal.
Again, it's not Earth's surface; it's the elevation line.
But tangent point is
the elevation line.
Tangent point should stick to Earth curve.
To the curved elevation line, perpendicular to the elevation line.
But this is not tangent.
It is.
No, it is tangent to what?
See, perpendicular to level, did you want to say?
Tangent to elevation?
Yes.
What it is? Tangent to elevation.
Imagine Earth. Now, add 529 feet to it and make the sphere bigger. That sphere.
So we have two spheres, one bigger and one smaller, and they two exist at the same time. Great.
It's elevation line.
So
doesn't
this is
exist. It's not exist. It's
oh,
just an elevation line. If you go and build, put some stuff at elevation 529 all over the world, you will get sphere at that elevation.
imaginary sphere.
Yes, we're not going to build it.
So this is this new horizontal is tangent to imaginary sphere.
Yes, the imaginary sphere that's at elevation 529 feet.
And this smaller tangent at
No, that's a smaller.
smaller.
The
It
bigger.
means it. No. I am talking this original, this smaller Earth. This is it would be real in your model. So we have two tangents, one to real, supposedly real sphere, and the second to imaginary sphere.
What real sphere? Do we have a porcelain sphere? No, we have water, which have waves, we have and tides, we have mountains, we have mean sea level. That's the sphere.
I mean this 529.63 foot height.
Right.
This is marked as tangent point.
Right.
So this is real tangent to real sphere in your model.
Tangent.
It is not tangent?
What? Not real tangent.
Not
tangent.
real?
It's tangent to the 529 elevation sphere.
So both tangent.
Sphere, right? There's mountains, there's valleys. There's no 529 feet sphere, but you can think of it as a sphere at 529 feet elevation.
Okay, so we have two imaginary tangent lines.
Yes, it's a problem.
Tangent points, I mean. And both are tangent to imaginary spheres. So there is no spheres, no tangent points really, only imaginary. Great.
Right.
But still, Dogma wanted to prove that the real Earth is curved, not imaginary Earth. So, so he didn't prove anything, like you.
Well, again, when you take this data, the elevation points, they give you the data, and you plot it on a graph with a straight baseline, you get a curved line. And we know this thing is not curved, right?
What is not curved?
LIGO.
But why is your elevation profile curved?
Because you draw it on a graph with a straight baseline. And our baseline is not straight, it's curved.
Is it not horizontal?
Yes,
Our
Bev.
baseline? No, it's level.
Bev, as Ali said before, it would have consequences that they are straightening curved line.
Yeah.
That's why they have
yes, I know, but I don't want you to tell me.
No, but they know what they are doing.
Yeah, but they won't say it for themselves. I want them to say it.
But he already said that.
What straight line? What the curved line we're straightening?
There you go.
Which lines we talking about?
You said level. Did you said level?
Level is curved, yes.
But you said also that this level line is straight in elevation profile drawing.
No. Listen, the level line is straight in the elevation line profile. That's a problem. When you take something that is really straight and you draw it in the elevation profile, you get a curved line, even though that the thing, LIGO, is perfectly straight. Because you used straight baseline when in reality the baseline is level, yes, or elevation, whatever you want to call it, is not straight.
Yes, so he admitted that, Bev.
Yeah, I know, yeah. Thank you. Thank you, Chucky.
I
So
admit,
you curve the x-axis, right?
What do you mean we curve? We don't curve anything.
No, well, the x-axis is horizontal, right? And then when you draw your elevation profile on that old school graph, you end up with a curved line.
Right.
Right. Yeah. So how do you make that curved line? Because it isn't curved in reality, is it?
Again, because the baseline, which we take the measurements from,
the horizontal,
is not straight. No, the level is not straight.
Okay, so the graph you have to put it on has a different shaped x-axis than we are used to. That's what you're doing.
No, you don't. You just need to realize that Earth is curved, and this curve that you see is not the curve of the structure.
But you're not using the old traditional horizontal graph system, are you? Because obviously you end up with a curved line for a straight.
Well, if you look at the blueprints, I'm sure the lines that the baselines that they refer to are curved, very slightly because it's only 4 feet on 4 kilometers, but they are lower at the 529, and they are higher at 533. And since this structure is straight, they draw it straight. The line it is above is curved.
What do you reckon about Blue's thing of Lake Pontchartrain then? And Jesse Kozlowski's. Well, Lake Pontchartrain. Yeah. See, because that goes the opposite way, doesn't it? That's what got me. I thought it was amazing. Because that's why we went from this to LIGO. We went from Blue Marble Sciences, Lake Pontchartrain with the hump, the 90-foot hump in the middle. And we went to LIGO, and we found out that LIGO elevation profiles curve the other way. A horizontal line looks like it's like some sort of a weird freak show when you plot it, elevation profile somehow. But Blue Marble had an elevation profile that had a hump in it that went the opposite way. I thought that was really weird, that.
That's the surface of the Earth, and that's the LIGO. LIGO is straight, surface of the Earth is curved. Now,
so wait a minute.
When you look at Jesse Kozlowski at the what's his name picture,
yeah,
it's evidently it's curved. You see, it's curved.
Because it's definitely curved. Yeah, he's measured a hump. Blue said Jesse Kozlowski was aiming to measure the elevation above the tangent plane.
No, Jesse Kozlowski measured the XY coordinates in the GPS system. That's what he did.
I'll get you a clip for you. There we go. Check this out. You can click it for yourself. Listen to it. I'll do it for everyone.
What Jesse is trying to measure is the elevation above the tangent plane.
See? Click it for yourself, Chikey. Go on. Blue Marble telling you what Jesse was doing.
The elevation above the tangent plane. What he's talking about, I don't know.
See the picture just above? It shows you the elevation above the tangent plane.
As you can see on this drawing, tangent plane or tangent line is below surface of the Earth.
Yeah, and it has two tangent points as well, one at each end of it. He's put the yellow dots there. Look, they've got to be the two tangent points for the tangent plane, haven't they?
Look, I don't know what he's talking about, so I can't comment.
No, I wouldn't either. Yeah. But you see the curve that he's got there? It goes like downwards at each edge. But when you do the elevation of the LIGO arm, it goes up and that's straight.
Ben, LIGO is one of the few structure on Earth that is built straight. Nobody built anything straight.
No, I've never seen an elevation profile like Blue's done. It's amazing. Let me get the other one. Have you seen the LIGO elevation profile that Blue's done for us?
I probably did. Not sure.
You probably did it. Did you have anything in?
I usually watch his videos. So
do you not check out everybody's work first? Do you not?
I don't remember. I see a lot of stuff. I don't remember each video.
Well, I know this is new. This is like brand new, right on the cutting edge. You see that? I've just posted it in there. That's the elevation profile of the LIGO. Welcome to the globe. If that doesn't make you want to get straight into the globe, I don't know what will. Actually, it's the blue line that's the LIGO straight arm with the elevation profiles. 'Tis globe, says Blue. See, it matches up perfectly with the matching the elevation above the tangent plane, doesn't it? I love globe geometry.
Yes, well, it's nice because if you put a tangent line below the surface, you will end with elevation profile with hump, and if you put this tangent above the surface, you will end with concave profile.
Yeah, it looks like he's drawn a chord line, which is genius. It's got an elevation profile. The orange line is a straight line connecting the start and the end of the LIGO northwest pad. The orange line is a straight line. The blue lines are the actual elevation. So the blue line is the straight line. Yet he's even drawn a straight line connecting the two ends of a straight line in elevation profile. That's genius.
Yeah, well, I must tell you, it confused me a bit. So,
welcome to the globe, Chike. Welcome to the globe. You're meant to feel thoroughly confused constantly. So, effect done.
Yes, and even Ephidogma admitted that this is geometrically impossible. Welcome to globe.
For one line to have two tangents for two different concentric lines. Nobody says it's the one line that has the two tangents. Again, I'll repeat it every time.
But it is the line AB.
Right. Which
and
is
there is a tangent point at A and a tangent point at B.
No. Tangent line AB is tangent at A. End of story. At B, it's the line BC that is tangent.
Yes, but we are talking about,
like in my drawing.
But we are talking about one supposedly curved level, not two levels, different levels on two different spheres. We are talking about one curved level.
No,
Yes.
Because no.
Yes, we are, Chikey.
How can it
It's
be?
you're able to
how can it
separate
be?
the two lines, even
How
though they've got
can
a
it be?
common corner point.
How can it be the same level if one is 529 and the other 533? That's 3 foot difference.
Because we supposedly live on one Earth, not two different Earths.
Again, don't care where we live. You say it's
care.
the same. It's the same sphere. How can it be the same sphere? Assuming it's a sphere, how can it be the same sphere if one is 529 elevation and the other is 533? It can't be the same sphere.
He has to
One
have
is higher
many
than the other.
circles.
One is farther away from the center.
So why it is labeled as level? Because it is one level. Do you agree that on Earth it would be only one level?
Really? Really? Where is this level? At what elevation? At what elevation is this level?
I can give you only this curved level. Let it be. For the sake of argument, let it be curved level. How many curved levels you can have on a sphere?
You tell me. I live in Israel.
No, you tell me.
I live in Israel. We have the Dead Sea 400 meters below sea level. Is it level? We have the Sea of Galilee, which is about 200 meters below sea level. Is it level? We have the Mediterranean, which is at sea level. Is it level? Which one of them is not level? Jesus.
Okay, so these are not real levels of real Earth. Thank you.
What do you mean not real levels? If you build something level, is it level or not? You build it at 1 mile up or you build it at sea level? Is it not level 1 mile up? Is it no level at sea level?
When it's their paralogisms, they're never going to get it. I understand your frustration, Paper.
We're never going to get it? Who? You're talking about your crew?
Well, we're just talking about level, right? And you're talking about the vertical datum. And then you're switching it to the horizontal plane. I get the feeling that you don't really understand what it is. Like you're switching it between two different forms.
What forms?
Well, you're talking about 200, yes, 200 feet above mean sea level. That's just a point on the vertical datum.
Yeah, but there are a lot of such points all around.
Yeah, you can have an elevation point for anywhere, yes, and it's just a point on the vertical datum.
Just a point.
Yes.
So suppose we hang something at that point all over the world, every half meter. Yeah, we have lots of points.
Loads of plumb bobs.
We have a point. And no, just a point.
You said hang. No, you said suppose we hang something.
Yeah.
Then you've got a plumb bob.
Perpendicular. Density disequilibrium, and it floats there in the air, and that elevation all over the world, right? So if Earth is a sphere, that's a sphere also.
What?
I need to hang something there. I can't see the sphere in my mind. There is no tangible sphere.
So you just imagine it.
Yeah, just like you imagine your level plane. Is there a level plane? Huh?
Yeah.
Did you fill everything with water? No, you filled a bit of your pipe here and a bit of your pipe there. In between them, there is nothing. So where is the plane?
No, the whole the water level. I don't think you understand how water levels work, do you?
I don't know. So
it seems like you haven't got a clue.
So is between the two points of the level anything? Is there anything between them?
The one body of water.
There is no.
In between in the water level, yeah, there is.
It's below them. It's not at the level of the water level. So what are we saying? All this gap between them Is nothing. Is not either
you can move
level.
You can move the
curved
end
level
of the
or
water
straight
level,
level.
right?
We don't need all of it to be level with water, right?
Yeah, but you could start with them right next to each other and then slowly move one end away.
Right, but there
Right.
all
And it
always
would be in a straight line.
No, it wouldn't.
Yes,
But
it would,
but at
Chaiki.
any given time, there will be 2 points. Only 2 points. There will be
Yes.
no plane, no line, nothing.
It does. It
There will be
establishes a
point
horizontal
here
plane of
and a foil
reference.
there. And in our mind, we say that's either flat plane or curved.
In your mind.
In our mind, yes, because there's nothing there. There's water here, and farther there is another water up in the air. Between them, nothing, air.
So you don't think a level is a tool for establishing a horizontal plane of reference?
Absolutely not. Come on, Beth. Do I need to bring the picture? You yourself too. Oh, maybe your son. I don't know.
I don't know. Go on. Let's see.
Of course you know it.
I don't know. I don't take much notice.
For pictures you take. Yeah, I know. You'd rather forget you took it.
I doubt it. I purposely don't put pictures out there that I don't want out there.
You do, make mistakes sometimes.
Really? By taking pictures? Or my son taking pictures and me posting them?
By posting them.
It's a mistake for me to post pictures. Really? Chaiki?
Can you explain to us, if level is flat, why are you looking
I've
at
never said levels
the
flat.
tower?
Why are you talking about that?
Why is the tower below?
That's a bad claim. Nobody's ever made that.
Why is the tower below your eye level? Are you above the tower?
I don't know what you're talking about.
What do you mean you don't know? Of course you don't know. You took this picture.
Which picture?
The one I just posted.
You posted a picture?
Hold on. No. Sorry, I posted it in Jose. Sorry.
Where is it?
Yeah, he hasn't posted it.
Oh.
Sorry, my bad.
Yeah, what's that?
It's a picture you took.
I think that one was DP.
Huh?
Yeah, I think that one was DP.
What do you mean DP?
DP took that picture. DP set the auto level up. That was the day we went up to take some pictures to get Ranty to go up Winter Hill, wasn't it?
Right.
Yeah.
So never mind the causes. So he didn't know how to set the auto level, maybe?
Who?
The one who set the auto level.
I don't know. It's just a picture, isn't it?
In this picture,
Mm-hmm.
in your auto level,
it's just a picture.
Right? It's calibrated.
Pardon?
It's calibrated, the auto level.
Yeah.
So if it didn't do any mistake, maybe we can ask him. So if it did no mistakes, for what reason the tower is below the center line?
We took the pictures so we could get Ranty, because everyone was saying nobody's making any predictions for Ranty to go up the hill, and he won't go up Winter Hill unless everybody makes a prediction. So what we did was, that day, we went out and took 3 pictures of Blackpool Tower through the auto level from different elevations, just so we could encourage Ranty to go up Winter Hill to take pictures of the auto level.
Good job.
Yeah.
Good job.
He didn't though, did he, Ranty? He didn't. He left, actually, didn't he? He left the globe defense. He left you all high and dry and went and did something else.
For fuck's sake, babe.
Did you not get upset about that, Chaiki? Like you had to stay here and do
not
this
at all.
shit?
Not at all.
No.
Not at all. I'm apathic to Ranty.
Okay,
Now,
so
I
what
didn't
is it you're
ask
saying
for your
in this then?
motives. I didn't ask for your motives. I asked, were you above Blackpool Tower when you took this picture?
I don't know.
Was your elevation? Because when
I
I
don't know.
talked to you last time, you said everyone, when Ruhif analyzed this picture and
Analysed
said
it. It was just a picture we took to
yeah,
try and
yeah.
help Ranty get
Hold
up the
on.
thing.
Oh, no. There is a video on Ranty's channel. Ruhif said,
Yeah, but it was
Bev
just a
here.
picture that somebody took from the auto level.
Right. And
in order to help Ranty
Ruhif,
get some predictions of what he was hoping to get.
Thank you for your support. And Ruhif said, Bev was here in this place. And you said,
I told
everyone knew where I was.
Yeah.
So you didn't deny, you never denied where you were.
No, I told
where
everybody.
it's
We went to 3 different positions to take a picture of Blackpool Tower through the auto level.
I only saw this one.
Oh.
This one that Ruhif analyzed. And in this position, you were 120 meters above sea level, which is still below Blackpool Tower. So for what reason is Blackpool Tower below your eye level?
It was a
If level
picture
is
taken.
horizontal, level is horizontal.
That crosshair at the eyepiece.
It's horizontal, right? So it should intersect the tower somewhere in the middle.
No, you don't use auto
or below the
like
top.
That. No.
I don't use, but
yeah,
you did a good job and you took a picture, which is
yeah,
quite clear. I must say.
No, yeah. If you look in that shot, that's one of the only shots that you'll ever find that there's no measuring rod in, because I always make sure that the measuring rod is in the shot. Because that's how an auto level's used, with the measuring rod.
We have a measuring rod.
Where?
We have a thing called Blackpool Tower.
Which
we know is height. We know its elevation. We know exactly how much it needs to take in a field of view. And Ruhi, find your place based on those measurements, on the angle size of the
I
tower.
told everyone where we were.
You see, so you told everyone.
Yes, I told Chad specifically. I said, Chad, can you get us one of your eye level pictures? And I gave him the picture so he could do it.
Great.
So I told him where we were. I told him about all of it.
Yeah, you did it live. It doesn't matter. You were below Blackpool Tower. And if you below Blackpool Tower and horizontal is
let me say it again.
Straight,
let me say it again.
Your eye level should be below the
DP. DP set the auto level up. DP did it all himself. Chike.
DP, I don't know who's DP. Now it's DP.
Right, okay.
Now it's DP. So you say it may be that DP didn't know how to set this.
No, I'm just saying it's a picture we took that isn't anything to do with any surveying or any horizontal. It is literally taken to help Ranty, to give him a little bit of encouragement, to say, go on, Ranty, you can do it. You said you were going to do it. You've got the money off people to go and do it. You've got it all funded. You get a chance to go out with cats and have a day out. Go up Winter Hill, Ranty, and just do it.
Well,
he didn't. We tried our best. We were the only ones that tried to help Ranty get up there. You guys just didn't care. You just left him alone. That's probably why he left. Because you just didn't encourage him at all.
No, it's not that. Ruhit
so this
was supposed to give it the money for the auto level, right?
This was a trolling picture? Is that right? So you're saying it was like a troll picture to begin with?
What do you mean?
Troll?
Are you saying that this was like a picture to mock somebody, to incentivize them?
No, listen to it again, right? On that day, DP came down and we did a few tests. We went out to Blackpool, we went out to Southport Beach and did an auto level test for Stadia Hair, where DP got a chance to use the auto level, right? When we went down the beach, looked down the beach, we did that to Blackpool Tower. So you could see Blackpool Tower at sea level, because we were at about 0, maybe 2 or 3 feet above mean sea level when we did the first set. And then we went close to where I live and sighted Blackpool Tower from a different elevation. And then we went to another height. So we did it at 3 different heights at 3 different distances away. We took a picture through the auto level to aid Ranty, because everybody was saying, ooh, nobody's making a prediction. I predicted that Ranty wouldn't go up Winter Hill. Turns out I was right. But I was trying to help him. I really wanted Ranty to go up Winter Hill and set up his auto level, because I say nobody would ever have done that before. That would have been a first.
Ranty don't have auto level. Ruif was supposed to equip him with
He did.
auto level.
He bought it. He said it was at the shop. Yeah, he's bought it. It was at the shop up by Katz's house. It's still there. It's paid for. It's waiting in the shop for them to pick it up.
I asked Ruif why Ranty is not going, and Ruif said, we presented the challenge to Flat Earther, and we are waiting for a prediction from a prominent Flat Earther.
Mm-hmm.
Lemon Bird did make a prediction.
It's a prominent Flat Earther.
But no, that's it. That Ruif says he's not a prominent Flat Earther. He wants someone like Beth.
I'm not a Flat Earther.
So nice though.
Okay.
Yeah, I know. He's like Lemon. Like, I'm not a Flat Earther. I can't be a more prominent Flat Earther than Lemon when I'm not a Flat Earther. That's pretty bad.
That's what you're saying.
That's what you think of Lemon. That's bad.
You're a horizontally level Earther. And most of the...
not the Earth. No. Just level is horizontal. It's got nothing to do with the Earth.
Most of Earth is level, right?
No.
70% water, not level?
Absolutely not. I mean, you don't think tides and waves are level, do you?
I mean sea level. That's why we have the mean.
The mean's a mathematical average, dude.
Right.
Well, you can have a mean of a mountain if you want. That doesn't make the mountain flat, does it?
No, it makes the mean flat.
Yeah, but we don't live by means. We live in reality.
Yeah, so when you have tide in the UK, 10 meters high, I don't know what tides you have there, 10 meters high tide, how much do you think that changed the level of water across the Atlantic Ocean?
What?
How much the level is changed? What would be the
Chaiki,
change
whoa,
in the
you're
level?
breaking down again, mate. You're breaking down. You're not making any sense. You should regroup. Have you not got anybody to tag you out? You're struggling here.
I'm not struggling.
Right,
I'm
what's
saying
the tide got to do with me in the Atlantic? How the fuck would I know?
How much the tide going to change the level?
I haven't got a clue.
Even be able?
Would there be waves?
No. Would you?
There wouldn't be any waves in the ocean. Oh dear, what's happened?
Well, I was in an ocean that had almost no waves.
Almost
in the Philippines.
So there was some waves.
I was amazed because I live by the Mediterranean, and there's always waves. And I came to Philippines, and the ocean is like almost a mirror.
Chike, everybody here knows you're a waste of space, and I don't know what you're trying to do. You're trying to talk to us about level, but talking about the Atlantic Ocean with the tide near me.
Yeah, no, it's you that say you're
I'm
not a
saying it's
flat
not
earther.
level.
What are you? What are you saying? That level is horizontal?
Yeah.
So I'm showing you the picture. If
Level,
level
in
is
fact,
horizontal,
level is
why
a
are you
straight
looking at the
line on a
sky?
horizontal plane.
Why are you looking up at the sky and not at Blackpool Tower? Why your crosshair are not on Blackpool Tower
Why
at
was that?
180 meters?
Why was that
I'd like to
picture
point out,
taken?
Chike, that there's no measurements on that picture. You can't tell what
Oh, there
elevation it
are.
is or anything.
Oh, there are. You see those lines?
Yeah.
You see those lines? Those are measurements.
I understand.
They're not. They're
I
just
found.
lines,
That's
Chike.
how I found the distance Bev was from the tower, by those lines. And by knowing the tower size, I knew how far he was. I didn't know where he was, but I knew how far he was.
Assuming it's level. I mean, it's just a lot of
No, not
assumptions.
assuming anything.
They did know where I
Assuming
was
the
because I
lines
told everyone where I
are
was.
doing what they are told. We are told they do.
And we do live on a coastal plain, so places overlooking Blackpool aren't that many. So, you know, you probably could work that one out for yourself.
What I want to know is why your crosshair are not at the 120 meters on Blackpool Tower. Why they above the 160 meters?
I don't know. I don't know where they are.
Above the tower.
You don't use an auto level over that distance.
I do.
Do you?
I do. Yes.
Wow. Let's see some of your pictures
Quite
then.
efficiently. I don't need pictures. You bring the pictures. I use your pictures. I use your pictures to show that Earth is curved.
Oh, come on, Chike.
What can you do? Once
you took a picture
that
we took to help and encourage Ranty, and you managed to do some phenomenal new globe surveying techniques to measure the shape of the Earth.
Your motives are irrelevant to me. I have
it's your motives,
and I can
Chike.
get whatever
Listen to
data
yourself.
I want from this picture.
You can take whatever you want from a picture that somebody else takes.
Data. Right, yeah, right. I can't.
Absolutely. And you ended up saying, "'Tis globe," right?
I'm telling you, if you are 120 meters, why your eyes are
is that what you
looking
put?
at the sky?
Let's have a look at your
why
picture.
Are you looking
did
at
you
the
write
sky?
"is globe" on it? I hope so.
Why are you looking at the sky? If you went to Winter Hill, you wouldn't even maybe see the tower. It would be so low in your field of view, you wouldn't see it.
So what is the thanks Bev for?
That you proved
allowing
that
somebody else to take a picture
is above the tower. That's why.
My eye level.
Eye level, that horizontal line.
Eye level.
Mm-hmm.
Horizontal.
Horizontal line is your eye level.
Level.
Is it not?
So level is horizontal then?
No. That's your eye level.
Yeah, level, horizontal.
Not horizontal. Absolutely,
yeah, that's what you're saying. Eye level is the horizontal.
No, I said the horizontal line, Bev. Don't try to twist my words.
Yeah, but it's horizontal, right?
The line is horizontal, yes.
Across, it's like in the eyepiece, right? That line.
Yeah.
Okay. Which is about like an inch away from your eye?
I don't know.
You don't know? Because I don't know. Like, you've never done that. You've just looked at pictures that other people have taken.
I don't need to know how far it is from the eye, Bev. All I need to know...
Can you remember that thing that Jeff said? Where he was trying to say that you... Remember that you could... we looked at his crosshairs and noticed that they weren't the same horizontal. And he said... Can you remember what he said?
Who?
Jeff. The fake surveyor that used to pretend he was a surveyor. He took two instruments out to look over water, right? And he was looking at a lighthouse, and like the horizontals weren't the same. And he said that you can just put your camera over it and it moves the crosshair up and down all over the place. It's not standard surveying practice to put a phone camera over the eyepiece of a...
That's true. It's not at auto level.
Mm-hmm. So, like, that crosshair could be anywhere, right? You can't take what that is because it's just a picture of an iPhone over the camera. It's not a surveying technique or anything, is it?
Hold on. The auto level is 30, right? You can tilt it up and down.
What?
Can you tilt?
That's what Jeff was saying. Jeff said that you can move the crosshair by putting your camera in a different place. That's what Jeff said.
Right, with the theodolite, but not with auto level.
What? It's the same. It's the same sort of eyepiece.
Can you move the auto level up and down?
No, that's not what he was saying. He was saying that you can just by putting the camera. I mean, have you ever done it? Have you ever tried to put an iPhone camera over an eyepiece of an auto level? Because they're tiny, they're little tiny eyepieces. Have you ever done that, Jake?
I see, and if you move the camera, the crosshairs move.
I don't know. That's what Jeff was saying.
Well,
did you not know about that?
No, I don't know, Jeff.
Oh, yeah. Well, you don't know about obviously putting cameras over eyepieces, do you?
I do know because I saw Jesse
Kozlowski. Yeah, Jesse Kozlowski puts a disclaimer at the beginning of all of his videos, doesn't he? To say this isn't standard surveying practice.
Right, and from Jesse does it, and main surveyor does it.
Yeah, where have they gone? Because From Jesse isn't a surveyor.
Still here.
He's not a surveyor though.
Does it
he bought a broken fixer upper, and he hasn't got it calibrated. He's told us that.
What do you mean he hasn't done it calibrated?
He hasn't had it calibrated. No, he bought it as a fixer upper off eBay, and then hasn't had it calibrated.
You don't need to have it.
Of course you do.
I'm sure he has it calibrated.
He hasn't got it calibrated. I can tell you. I've asked him.
In a shop, he can calibrate it himself.
He can't. He hasn't calibrated it himself.
Yes, he can.
Chikey, we've talked to him.
You can too. Okay, I'll talk to him.
No, we've already talked to him.
Well, look, I've been here for a few hours today, and Effie Dogma said one thing.
Effie Dogma didn't say anything.
Effie Dogma said one thing, and you said a different thing. Effie Dogma said,
"What did Effie Dogma say?"
Tangent line, two tangent points, two tangent lines. You said one line, two tangent points.
No, I said tangent point at A and a tangent point at B.
Right, but AB is not tangent at B. That's it. End of story.
The line AB does have a tangent point at A and a tangent point at B. It's an impossibility. He admits it's an impossibility.
Well, I showed you how it's possible. It's perfectly possible. There's no problem there to have a tangent point of BC on the line AB. There is no problem at all. Actually, there must be a tangent point there.
Well, there must be two tangent points.
Absolutely.
Wow. I thought it was a model dictates
of two different tangent lines, as I showed you. If I draw another circle, there will be a third tangent point of a third tangent line. Not a problem, Beth.
There you go. There you go, Chikey. That was the first part of the day where we went out. So you can see there how the Stadia hair works. We've done all of that, right? That's where you learn how to do stadiometric range finding, right? We taught you that, didn't we? All the way through the internet, like, yeah?
No, you didn't teach me.
Yeah,
However,
you'd never done any surveying, stadiometric surveying before.
However, I
until we showed you.
No, I never watched you teaching this, and I found the distance you were from the tower without your help, Bev, only by your picture.
The stadiometric range finding, you wouldn't have known about stadiometric
Without no
range finding
stadia,
if it
I don't
hadn't
need
been us
stadia to find
going on about it.
I don't need stadia. I need something I know its size. That's all.
You just need its size.
Yep, just its size. Size and distance will give you the tangent of the angle. That's all I need.
The tangent of the angle?
You said you found the distance.
Right. Because I knew the size. I knew the size and I knew the angle.
The angle?
You sound like you're full of shit.
I knew the size and knew the angles. I must know the distance.
What angle?
The angle the tower takes in the field of view.
Which angle, though? I mean, that sounds like Ruhif's opposite side angle.
The angle the tower takes in the field of view.
But it's an auto level. It doesn't measure angles.
Yes, it does.
No, it doesn't.
Those stadia lines are angles.
No, they're a ratio.
Don't tell me no. Well, this ratio, if you don't mind, is 1 milliradian.
It's 1 to 100.
Right, and 1 to 100. Divide 1 by 100. Let's do it now. Move to radians. Let's take 100. 1 over invert tangent. That's 10,000 of radian. There you go.
For what?
That's 1,000, 10,000 of a radian.
A radian of what?
A radian. It's an angle.
No.
You don't know
an
radians.
Angle is an angle.
An angle.
Mm-hmm.
You can measure it in a unit that's called radians.
Yeah, but a radian is like it's like pi, isn't it?
Right. And this is 10,000.
But a radian, the actual size of the radian increases with the size of the radius. So what is the radius?
I don't fucking care about the radius. I didn't.
So you're talking about a radian? How do you talk about a radian without talking about the radius? Or you're talking about an angle? Right, well, where do you get the angle from? Because it's an auto level.
From the stadia.
There's no angle. It's a ratio of 1 to 100.
The fact you don't know that it measures an angle, it's not on me, Bev. It's
measure
on you.
An angle.
Yes, it is.
No.
Because you said
auto levels do not measure vertical angles, Chike.
So it measures 1 over 100. 1 over 100. Those two big lines, right? So the whole stadia from top to bottom is 10 milliradians.
It's at a ratio of 1 to 100. You have to have
1 to
something
100.
To measure.
When you divide.
This is embarrassing, Chike. Remember, you are just talking about somebody. You are somebody who hasn't ever looked through an auto level. You're only doing this from Discord because you've looked at other people's pictures and imagined you can do things that are actually impossible. You don't have the power of the globe behind you, Chike. You don't have it.
Impossible. And now, however many times you used auto level and I didn't, I found your distance from the Blackpool Tower. How did I do it? Did I guess it to 100 to 200
Ruhif
meters.
found it.
Did I get no? I guessed it, and Ruhif
Even though
came
I
up
had
with
been
a
told
number
everybody where it
pretty
was.
close. I calculated 32.4 kilometers, and Ruhif had maybe a slightly different distance. Doesn't matter. I found your distance pretty accurately with using angles, which you didn't know your Stadia measures.
And definitely not because I told everyone where it was. So everyone would know how far away from Blackpool Tower I was. Then they could tell Ranty that these different distances and different views of Blackpool Tower was something that he could go and just do a bit further.
Yeah. When
because you remember I predicted that Ranty wouldn't go and do it. It'd be too historic for him. It's like Rumpus. Rumpus won't do his test either because it's just too much. The fame would be too much. They'll be making statues about him and stuff, and you can't have that, can you?
But that wasn't the prediction that was asked to be predicted. If you predicted what the Ruhif asked,
no, I just took three pictures for him.
No.
Yeah, just to let him know that he could do it. He could do it, really.
Rohit just asked,
it's a possibility that he could have done.
Where would the top of the tower be in the field of view of the auto level? That's all he asked. Maybe if you answered it, Ranty would go.
Yeah.
But nobody answered it.
I did. So I said Ranty wouldn't go, and therefore you wouldn't be able to see Blackpool Tower because it's.
Listen.
It'd be too historic for him. I did say that. He could have gone out and with cats and gone skipping in across the fields, him and cats, doing it together like buddies.
You're always trying to avoid what we're talking about. Listen,
if
you need to guess 6 numbers in the lottery, I can make a prediction that nobody's going to win 6 numbers next week. However, when nobody wins 6 numbers next week, I don't get anything. It's not what I was asked. I want to win the lottery, I need to.
I wanted Ranty to do it. I was trying to encourage him to go and do it.
No.
Yeah, we had gifts and all sorts. We did a sponsored day out, like all of us. Everybody did predictor. We had a predictor-thon for Ranty.
But he wouldn't go to do it without anyone.
Oh no, he wouldn't go and do it. I made a gif about that as well.
There was a challenge. What do you want? There was a challenge. Where would be the tower in the auto level view? Nobody took the challenge and said here. Nobody.
Except for me. I did some. Here it is at this height, and here it is at this height, and here it is at this height.
No, we didn't ask
that's
you
what we did.
What it is really. We asked for Rohit.
You like as though you were part of the team.
No,
Chike.
I wasn't.
Sound like you're a big man. You're bigging yourself up there, Chike. I like it.
I'm correcting.
Yeah, you're definitely one of the men.
I correct.
Somebody sign this guy up. He's big man, big team.
I immediately corrected myself.
I like the way you came in like that. Yeah, no, it was we. It was we. You're grabbing that as well.
It wasn't we. I have no affiliation to Ranty.
Well, you said we. It's like you and your big team.
Well, I corrected myself. Look, I put in chat, in YouTube chat, I said something. Flat Earth, and then I said, oops, sorry, level is horizontalers. And someone said, no flat earthers here. Yes, I corrected myself already. What do you want?
Mm-hmm.
So back to the question, Pat. Why is the line above the tower? Why is it not at the 120 meters mark? Which I don't know where it is, but it's not at the top. That's for sure. It's 40 meters below the top.
Right, you've measured that. Even though you know that you shouldn't really be taking pictures through a crosser like that.
Yeah, no one said you shouldn't. Said it's not a common practice.
Check this out in the live chat there. How'd you like that? What will the crosshairs be when Ranty doesn't take an auto level up Winter Hill? And there's 4-foot elevation for 12 miles. 110-foot elevation at 17.7 miles. And 380 feet elevation at 20 miles. Which one of those were the ones that you guessed, Chike? Maybe one of the ones that I'd already put in a fucking picture.
You're 20
and told
miles
everybody.
Away. You're 20 miles away. There is no 380 foot there.
What?
You were at 20 miles. You were at 32 kilometers.
20 miles
About
there,
20
it looks
miles.
like, doesn't it?
Yeah, the bite.
That's the one that you guessed.
Guessed what?
How far away we were.
I wasn't part of the challenge. I'm not a prominent flat earther.
No, but you are saying that you, Chikey, the great Chikey, managed to measure an unmeasurable angle within an auto level and predict that I was so far away. Now, which one of those was it that you predicted how far away we were?
32.4 kilometers.
Is that 20 miles then?
About 20 miles, yeah.
20 miles, right. So all you could have done is just seen this thing that I posted and then converted it to kilometers and then claimed a prize of being a genius.
I never saw you posted anything.
Obviously not. I mean, how could anybody doubt that you didn't do a massive calculation of an angle that's unmeasurable within an auto level that doesn't measure vertical angles at all? Even stated within the fucking manual that it doesn't.
For fuck's sake. I was at Geo's, and not Geo, what was his name? The one that took Ranty's servers. I was at this server, and someone came with this image that I don't know where he found. He saw you posting it.
Well, was
and
it Chad?
We asked him to
Chad
say where was it?
Because I gave it.
No, it wasn't. No, Chad. No, Chad. It was a Glober. And we asked him.
Wow, he came bearing gifts.
Where was he? And he said, you don't answer. He said, you don't answer. You don't give an answer where you were.
I definitely did. I definitely told people while we were doing it. I made a meme of it, and we definitely told people afterwards. Yeah.
Wait. Is it possible that you told people where you're doing it and when you're doing it, and you had the live view, and I didn't know where you were? Is it possible?
Is it possible that you didn't know where we were?
Yes.
I guess so. Yeah.
Yeah. So.
Well, I guess like you'd be a genius. You would be like. I mean, you would be hailed as a genius.
But I didn't know.
But if is it possible that you might have known?
It's possible, but I didn't know.
And it wouldn't be as impressive, would it? If you might have known about it.
Look, right. I told Ruif, this is the picture Bev posted. And he was very excited. And I think he tried to get some information from you, but you didn't answer. So he went and did the forensic himself.
Yeah, Ranty said, I'm not going to do anything unless you cowards can predict what I'm going to do. That was Ranty's tactic, wasn't it? It's a genius move. You can see why he moved from flat Earth to Globe.
There was no point. Why would he go there and take an image of something no one predicted? What for?
Yeah, because nobody was predicting what he was going to do. Then why turn up? Why do it anyway if nobody's predicting what you're going to do?
You see.
But I did predict that he wasn't going to do it, and
I'm telling you,
I'm right.
Bev,
I was right.
Bev,
I won the prize.
I'm telling you, Bev. Why is the tower below your eye level? And you start with your stories. We did this and we did that. That was my motive. I don't fucking care. I asked you, why is the tower below your eye level when you're in fact below the tower? You're in lower elevation and you're looking down at the tower. Why is it, Bev? You never answer.
Yeah, I did. I think I answered about the putting the camera over the crosshairs and how that can obviously change and all of that. It's not standard procedure. Also, there's no measuring rod in the picture. So that also shows that it's not standard procedure. It's just looking through a 32 times scope. A bit like what Rumpus is going to do. Like not standard surveying practice at all.
Yeah, but
that's why I didn't do it. That's why I didn't do it, because I know how uppity people get about this sort of thing.
I'm asking you a technical question, simple to answer.
Okay.
When
I didn't do it.
Listen, when you put the auto level on the tripod, is it possible to tilt it up and down? Not with the screws that you level the bubble, but after the bubble is leveled, is it possible to move it up and down?
If you don't level it properly, yeah, you can do whatever you want.
I didn't ask. I assumed you already level it. Now that it's leveled, is it possible for you, with your hands, to tilt it up and down?
Yeah,
or is it
you just move the legs.
firmly bolted to the tripod?
Do you not know, Chaiki?
I don't know.
I tell you what, you should go for lessons in.
You see,
you
could say yes.
Well, I know, but you wouldn't believe a word I said, Chaiki. So I don't know why you're asking me for my opinion. Because you don't believe a word I say. In fact, what you do is take pictures. You misrepresent them, pictures that we've took on there to show people things. You take them and misrepresent them as other things and pretend that you, Chaiki, are doing surveying, stadiometric range finding with magical angles that you're imagining.
Would I ask you this question if I wasn't going to trust your answer? But you don't want to answer. That's okay. I have Bibble.
Yeah, because you're a worthless piece of shit, Jake.
Next time I see Bibble, I'll ask him. He has auto level. He will know to answer.
Yeah. That's good.
Now you start calling me name. Yes, like your crew. Your crew did it 3 hours ago.
Did what?
Calling me names.
Yeah, but you are a worthless piece of shite, Jake.
See?
Yeah. Everybody knows it.
Of course I'm worthless.
Yeah, you've got nothing.
However, with an angle that I couldn't measure, I knew your distance from the tower.
When I'd already told everybody. So you are fantastic,
You
Chaiki.
don't know that 1 over 100 is 10 milliradians, Bev. That's the fact.
Yeah, an auto level does not measure vertical angles, Chaiki.
It does.
It does not.
So, really?
Absolutely, yes. But type it in Google now. Does an auto level measure vertical angles?
Can I move? Can I draw a line?
That's the ratio of the stadia hairs in all optical measuring devices.
Can I draw a line from my eye to the top of the stadia?
You wouldn't believe how many times we've had this conversation, Chaiki.
Can I do this?
It gets old.
Can I do this?
An auto level does not measure vertical angles at all.
Definitely
ever.
Does.
Have you ever looked through an auto level at all, Chaiki?
Need to. You see, I don't need to. Looking through something.
This is why you're a worthless piece of shit, Chaiki.
Looking through something doesn't make you an expert about it.
But knowing an auto level does not measure vertical angles is not hard when you have a tool that does not measure vertical angles.
And here I'm measuring vertical angles with auto level.
Yeah, from Discord. looking at a picture that somebody else has taken from a camera phone.
Yep, no problem.
Through an
no
auto level.
Problem, Bev. Yeah. No problem.
Mm-hmm. Mm-hmm. It's pretty embarrassing, Chikey. Have they not got better than you?
You can test me. Find another thing we know its size. Take me a picture with your auto level. Let's see if I know what distance you were from it.
See Ranty there. Can you see Ranty there? In that picture. Does he look like an experienced guy with his camera on a tripod?
So, did we close the two tangent issue?
Toothpick tangent. I think we ended up with a toothpick tangent.
No, well, I didn't use toothpicks.
No, you just drew a circle on the other side, didn't you?
Right.
Yeah.
Yes.
Yeah, left Wally
Basically,
out high
what
and dry
Dogma
with a
did.
3D sphere.
Basically, what Dogma did, but he only had an arc.
Yeah, but what's Wally meant to do with the toothpick tangent? Do you not feel a little bit guilty?
No.
That's
excellent.
How's Wally meant to make B a tangent point?
If I had a ball and this triangle roller, I'll do it.
Yeah. Would you be a toothpick tangent?
Definitely, yes.
Yeah, I would as well. Toothpick tangents are getting a thumbs up.
You see, instead of addressing what's being said, you need to concentrate on the toothpick. Because that's what's important, right, Bev?
How many hours?
How many hours you spent? That's the question.
No, how many hours should I spend on the toothpick tangent?
About 5 minutes.
Oh. You reckon that's how long it takes?
It never had to get to the toothpick. It did it only after you've been weeks in this shit. Right? You didn't do it right away. We're already talking to Effie Dogma, maybe? Blue Mamba? How many shows you did before he came with this?
With the toothpick tangent's pretty recent. It was because of Effie
right?
Dogma. Yeah. Effie Dogma helped us out big time with his twin tangent conundrum.
No, the twin tangent. How long this twin tangent? How long you discussed the twin tangent?
Oh, only like the other week when we looked at the video. I mean, it's an old video. Yeah, it's been full on though. You want to see it? Like, it's not like just been 3 shows. It's been like 4 days of it, full on. All sorts of Globers coming round doing this.
When you should.
Toothpick tangents. We've had twin tangents. We've had circles on the side. We've had extended arms radiuses. We've had Rumpus doing a live show on blues, doing his 5 rules for the globe. Did you see that?
No,
I'm going to have to go over that. Oh, yeah, you've been laid down some rules by Rumpus that you have to abide by. Like the sort of axioms of the globe, I think he was doing. You know, like Euclid has 5 postulates, the ones after you've got rid of all of the ones that you don't really want. Well, Rumpus has laid down 5 basic rules for the globe. It's getting big. Like Rumpus is going to be huge. I'm expecting there to be a statue built on the bridge at Welney.
Well, I'm asking because I put a comment on Effie Dogman's latest video. And I said
No way.
that will give you at least three 4-time-hour shows at least. That is my prediction.
Well, you've helped out tonight, haven't you? You've
Well,
extended it.
now
I
it
was going to
depends.
shut it off earlier,
Did
but
I?
you've helped us do a few
I?
hours. Yeah. Give Effie Dogma a shout out.
Yeah.
Go on.
Shout out to Effie Dogma. Now the question is,
Oh, come
would I
on.
be
You can do
correct
better than
in my
that.
prediction?
Effie
Would
Dogma,
I
the twin tangent conundrum guy.
There's no
Well,
conundrum.
shout out
Listen,
to him.
the
He's
question
brought
is,
Chaiki in tonight. Helped us out for a few hours of content.
he didn't.
Yeah.
He didn't bring.
And then no doubt there will be more because once Chaiki's been over, they'll all want to be. They'll be flooding over here now, Chaiki. Well, if Chaiki can do it, I can do it too.
Well, it seems
Chaiki leading the way. Thanks a lot.
Now the question is, would I be right in my prediction, or did I
You do predictions.
put sticks in my own wheels? My prediction is three times 4-hour show for Effie Doma latest video. The question: would I be right or would I be wrong?
Well, no, we've gone over Effie Dogma's latest video, but it's still the same issue. 2 tangents on one straight line.
I know.
Yeah.
Would you go through it again?
Well, I want.
Two
There's
more
no
times.
need. No, there's no need for me to go through the video again at all. The issue is
Right.
always the same. 2
There was
tangents on one line. A, B. Tangent at A, tangent at B.
And I showed you. it's not a
Very
problem.
simple.
Now, the question is not if you need to, because you didn't need to go through it even once, but you did. And the question is,
Why did he need to go through it again? Why did
I don't
Effie
know.
Dogma
I
feel
don't
the
know.
need he had to
Ask
go
him.
over it
I'm
again?
not-
Because he just
I'm not speaking
clarified
for
it
him.
again.
I'm
He
not
just went
speaking
over
for
the
him.
same thing. He didn't
Don't
make
ask
anything
me.
new at all. Well, actually, he did. He straightened up the north arrow that he seemed to have missed last time.
No, he simply added the other tangent. I don't think he had the first, the second tangent.
Oh, yeah, the horizontal angle.
Right.
The equipotential angle of adjustment. He added that in.
What the fuck? The other tangent, the tangent at B, he edited.
Yeah, where he added in the equipotential angle of adjustment. The one in between the two horizontals.
What?
I don't know. I don't know what to call it.
What is it?
I think
it's a tangent.
Do it.
It's called a tangent.
No, this angle. There. That angle in between the two horizontal lines. We're calling it the equipotential angle of adjustment.
What are you talking about?
That angle.
The
one that I've put a big question mark and it says A.
Okay. A.
Yeah.
Doesn't look like an A. Well, it's an angle. What does it matter?
We call it the equipotential angle of adjustment.
No, it's just an angle. Nobody cares.
It's an angle of 2 horizontals.
Yeah.
Come
It's the
on.
angle between 2 horizontal lines.
Ah, that's measured.
Yeah.
That's measured all the time. Between 2 verticals.
No,
But
2
since
horizontals.
No, listen. Surveyors measure angles between verticals. Reciprocal.
Angles between verticals?
Yes. Reciprocal angle measurements. They measure between the verticals. But since the verticals...
I would be hesitant to say that sort of thing because I don't know which surveyors you've been talking to.
They do. I'm not hesitant at all.
Well, I was talking about that one, right? On Effie Dogma's video, his new one. He has done that. And there is an angle between 2 horizontal lines. Now, we're just sort of letting you know for anybody that's listening as well, Globe Gang, that you're going to have to come up with a name for this angle between two horizontals, because this is big news. This angle being put out there for everybody.
Well, like I said, surveyor measure reciprocal vertical angles, and
what do you think about the equipotential angle of adjustment?
And they measure the other angle, the angle from the from the vertical to the line of sight. Yes, so it's always bigger than 90 degrees.
When you're measuring the equipotential angle of adjustment, do you reckon you start at the horizontal and look up to the horizontal, or do you start at the horizontal and look down to the horizontal?
Nobody cares about the horizontal. Nobody cares.
Yeah, we do. That's the sort of stuff we're
Nobody
after.
else does. Nobody else does.
But he's drawn it. He can't draw it and then say nobody cares about it. Why would he draw it if nobody cared about it?
Well, to show you, you can have a tangent there at point B. And how this
an
tangent
A and
look
B.
like. Yes, and in
so
order to
so
make
a tangent
line
point
going,
at A and a tangent point at B.
Right. You
on
need
that
to
straight
take
line,
this
there's two
line.
tangent
You
points
need
on
to
one
take
straight
this
line.
You need to take this line and rotate it around the right vertical until it's 90 degrees to the other.
No, it's got a tangent point on it there. Definitely
It
got a
is
tangent point at each end.
It is a tangent.
Yeah. But you
Which
said it
model
wasn't
takes it out?
earlier. It's definitely a straight line with a tangent point at each end of it. But it's not a tangent point at each end of it. But it is now, apparently.
What?
A tangent point at each end of
I
that
didn't
straight
say
line.
tangent point at each end of it. I said tangent point at A and tangent point at B.
Yeah.
Right.
A is the start of the line and B is the end of the line. The line is called AB.
Right, and the tangent is called
A and B.
No, it's called A, or you can call it A. It's the
and B. There's a tangent point at B, Chikey. Don't stop getting confused now. You've just said that there
the end
is.
station. Hold on. At B, there is a tangent for the line BC.
Yeah, there's a tangent point at A and a tangent point at B.
For the line BC. He just happened to sit on the line AB.
Chikey, you're showing us why you're a piece of shit. You've literally just said there is a tangent point at A and a tangent point at B. Now you're saying there is or there isn't.
No. I said there is a tangent point at A for the line AB, and there is a tangent point at B for the line BC. Again, I said it at least 10 times today. I can do it 10 times more if you need.
Yeah, but there is a tangent point at A and a tangent point at B.
Yeah, but the tangent point at B has nothing to do with the line AB other than it sits on the line.
Fucking 90 degrees.
It doesn't has anything to do with the line AB.
Yeah, it has. It's got a tangent point at B, Chikey.
A line,
get real. Come on.
On a line, a point. If I tell you, I have a line.
I tell you what you're doing, Chikey. 2D thinking. You can't get into 3D, can you? You can't work yourself into 3D world.
Yes, I am in 3D. I am in 3D. Listen, if I'm telling you you have a line AB.
Yeah.
And there is a line crossing AB at the line B. What does it tell you about the line that crosses the point B? Do you have any idea what's going on? Is there any information other than those two lines crossing at that point? Is there any geometric significance other than those lines cross? Can you tell me more? Anything that I don't know?
I think you're just making shit up at the minute.
I make shit up.
Yeah.
Because right now I told you.
Absolutely.
All that one point on a line tells you that if a line cross another line at some point, all you know about that point is that those two lines cross at it. And if the other line happens to be horizontal at that point, that's on the other line. Has nothing to do with the first line. Just because the point is shared doesn't mean shit.
It does in geometry, but I mean, like, you're just showing us that you're.
I just asked you. What does it tell me in geometry? Other than those two lines are crossing, what more can you tell me about this point B?
It tells me that you're a dishonest shit. That there's a tangent
you,
point at
and
B.
what you tell me,
You can't seem to get past it.
I asked you a question, which you say in geometry it has significance, and I ask you, what is the significance? You tell me I'm a piece of shit.
That there's a proof within geometry, Chaiki, that you cannot have two tangent points on one line.
I don't fucking care. Not what I asked. I have a point B, which is crossed by another line. What does this tell me? What does this signify?
Tells me
geometry?
That you're a piece of shit.
You see?
Yeah.
You said it has a meaning in significance in geometry.
Yeah, there's a proof. It's impossible. It cannot happen.
What's the significance?
That there's a proof that it cannot happen. Chaiki.
The geometry significance of the point
There
B,
is a proof that you cannot have 2 points of tangency on the same straight line, Chaiki. It is impossible. Effie Dogma says it's impossible. He agrees. It's impossible.
No, it's not what he said.
Chaiki, you're a piece of shit. Is anybody else finished enough with Chaiki? Because I've fucking had enough of this shit.
That's just too much.
The line cannot be tangent.
You're the third person today, Chaiki, that just will not fucking listen.
You can't have 2 points, tangent points on it. That's not true. The line cannot be tangent at 2 different points. That's true. That's what Effie Dogma said.
You don't even know what you're saying. No, you don't even know what you're saying, Chaiki.
Let's hear what he said.
Let's hear what he said. Go on and have a listen. There you go. Okie dokie. So, I think I've had enough of Chaiki for tonight. And it is 1:30, so we've done a pretty long night.
Triggered, didn't I? Huh?
No, you're just worthless piece of shit, Chaiki.
Okay, I heard you.
I'll tell you what, here we go.
Cunt.
There you go. He got upset. And then ended up swearing at us. That's why we got rid of Chaiki in the first place, because he is a worthless piece of shit. Anyway, so thanks for joining us tonight. Hopefully you've learned that globe model believers, especially like Chaiki, haven't got a fucking clue about geometry.
Chaiki's my spirit animal. Why did you boot him? He was doing good.
Yeah, obviously.
It was entertaining.
Yeah. Thanks for joining us tonight, Jose.
Good. That's doing good.
Yeah.
The longest I have heard the show. I heard the show for like 2 hours because Shaik was here. That's it. You get more people when you got an opposite view, you know.
On the what opposite view?
When you get an opposite view, and
an opposite view of what, Jose?
An opposite view of your paradigm, of your bias.
What's that?
What, of level being horizontal?
Like geometry, provable geometry, provable facts.
Yeah. Do you ever talk about spherical geometry, like reality, like planetary?
It's not reality.
Like in the big.
It's not reality.
Like in the big scale.
It doesn't make it.
Geometry,
it doesn't ever make it into reality, Jose. Spherical geometry never makes it into the 3D world.
You deny reality
that we live in. No, I don't deny reality. No, spherical geometry is only a conceptual 2-dimensional geometry, Jose. You should know that.
Deny science.
You should know that.
Spherical geometry, and you deny science and reality.
Yeah, just pile a load of shit on as well, Jose. Why don't you?
Told you
Why
what
don't you
it was,
try calling us
Jose.
racist as well or something?
It's not a.
No, I'm just calling you a reality denier.
Conceptual.
You're calling me a reality denier with what, Jose?
Yes.
It's embarrassing.
Spherical geometry.
It's not real. It's 2D, conceptual.
Maybe one time that I say it, not getting interrupted, maybe that'll be good. You are denying spherical geometry.
It's not real. How can I deny something that isn't real?
Well, Earth is a planet. Earth is spherical. We use spherical geometry. You're denying reality. Boom.
We don't use spherical geometry. Least of all, you, Jose.
He just goes blah 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 and leaves.
Mm-hmm. Wow, this is pretty interesting. Look at Wally now as well.
It's getting very strange out there, Bev.
Yeah. It's like Wally's posting the bit where F.E. Dogma says it's geometrically impossible for a line to be tangent to two concentric circles with different radii. He's posting that as though that's a win for F.E. Dogma. Saying it's impossible to do what F.E. Dogma's challenging them to do. This is getting really, really bad and really weird. The amount of people that want to keep coming in here to tell us about their model. Ridiculous.
What? So why are you still having these people around?
But they come in. They come in to talk. I mean, they're coming in to tell us about their problems with their model. I mean, it is getting weird, and I still talk to people because that's what I'm interested in, talking to people. But, I mean, is it good for them? Should we start not talking to them for their own good? Because, I mean, it is getting fucking strange, right? The amount of people that want to come over here and talk to us about basic stuff that they should be able to understand, that they literally cannot. It's really weird. Yeah, I know. Reality for them is like I don't want to upset their model, but it is a fact of reality that level is horizontal. It's definitely provable. Anyway, so thanks for joining us tonight, Busto. Hopefully I can get this and we're not got loads of different songs playing. Well, I don't know. What do you want? Anyone got any favorites?
You don't understand.
Yeah. The Brenda though.
That's my favorite.
LIGO and the Hump. There you go. Ooh, you don't understand. LIGO and the Hump. Thank you very much for joining us. Tomorrow, free for all Friday, but all day it'll be kicking off. It never stops. They've got something to prove or something. I don't know what. Join us tomorrow. Come to the Next Level Discord. Chike, you didn't break anything, mate. All right. See you later.
If you had a giant 1 mile long spirit level.
Imagine LIGO, right? It's 2 miles, isn't it?
Yeah, if you were to put a bubble level on like the intersection of LIGO, that would be level. If you were to walk down the arm and place it on top of that, I would say it would not be level. That would be another good.
So you say at the split point, that's where it's level on both arms?
Yeah, I'm pretty sure that's where they leveled it.
And what are the arms? What are the arms? If the center is level, how do you envision?
No, he said no, not the center. The apex where they both meet.
Oh, the apex.
Yeah,
sorry.
yeah, it's different.
So
It's changed.
how do you envision the end of the arms? then, the other two ends?
They're just going to go straight. And this is in the engineering.
At the end of the arms. At the end, you have the apex and you have two arms running along, right?
Yeah.
How are they? Are they in the same level as the apex, or how do you envision them? Higher, lower?
So at the ends of the arm, they had to pour more concrete because it was at a higher elevation.
It's not what I asked you. It's not what I asked you. When the job was done, you have your apex, it's level. Either arm, how are they in relation to the apex?
They're flat.
Are they
They're straight. They're straight.
Yeah.
Are they also
Straight
level?
No. They are... at each spot, they are not level. They like if you put a bubble level on the apex and you started moving down the arm, it would get off and more off level.
How? Towards the up or towards the down?
With the bubble level, it would either go left or right.
No, hold on a second. You have a level at the apex, and you have two arms running, and I'm asking, you say they're not level at the ends. So I'm asking you, are they lower than the apex or higher than the apex?
They have a higher elevation than the apex.
So they're higher than... Wow.
So the horizontal raises in elevation for you?
No.
No, you said it would be higher.
Hold on. The horizontal plane that was established at the apex will diverge from the surface of the earth. The horizontal plane stays straight, but the level of water starts diverging from the straightness.
What? How do you envision that? You envision level water diverging from straightness?
Yes, I do.
Wow.
How is that possible?
Because level is a curve. And water is level.
That's my model dictates, right?
No,
yeah.
That's reality. But as I was saying, like, if we go back to the straight line test, you would be able to see which one's true. If water is curved, then there will be an angle. If level water is curved, there will be an angle between B, A, and C. If water level is straight, then all of them will be collinear. It's a test.
I don't think there's any possibility of reaching you, bro. I just don't think so.
If we do the test, that would reach me.
At what point is vertical not perpendicular to horizontal?
It always is. Every vertical is perpendicular to its horizontal.
To its horizontal. And
yes.
What is a horizontal?
It's 90 degrees from its vertical, and vertical is defined from the plumb bob. I wonder if I could do it, because over a short distance, you might be able to use the Autolite app and a water level.
I mean, he obviously doesn't understand what level is.
You don't understand. Hold on.
It's not my problem if you don't want to learn. You're just on your own.
I can guarantee you there will be a hump in the middle. If you side across from one side to the other,
just take my word for it, bro.
No, don't take my word for it. Do it. I can guarantee you there will be a hump in the middle. There will be. I can guarantee there will be a hump in the middle.
There will be.
I can guarantee you there will be a hump in the middle.
Go and speak to anyone. Go up to someone that you know and just say, "Here, mate, is level horizontal?"
Yeah.
See what he says.
Horizontal, of course, level's horizontal.
Well, there you go then.
With level, especially when you do it on a small scale. Okay, if you're talking about the water level, the horizontal plane that a water level establishes is in the middle of the water level.
You would have to understand what a line is.
You don't understand.
I mean, he obviously doesn't understand what level is.
It's not my problem if you don't want to learn.
Hold on.
You're just on your own.
Begging for your model to be real.
You would have to understand what a line is.
No, that's fine. That's fine.
So logically, it follows then that all perpendiculars to that line
You don't understand.
are parallel to each other.
Yes, I agree.
It also then follows that that line cannot be a curved line or change angle anywhere along the line.
That line, yes. So this straight line we are using cannot bend because it's straight. I agree. That line, yes. So this straight line we are using cannot bend because it's straight. I agree. This straight line we are using cannot bend because it's straight. I agree.
I mean, he obviously doesn't understand what leveling is.
You would have to understand what a line is.
You don't understand.
You might be able to use the Autolite map and a water level.
No reason, no logic, no wisdom, no worries.
You don't understand.
You're just on your own.
Begging for your model to be real.
No reason, no logic, no answers to questions.
You don't understand.
You're just on your own.
Begging for your model to be real.
You know what we call a vertical change? You know when we measure a vertical change?
Yeah, it's an elevation change.
Yeah, a vertical measurement in the vertical.
Yeah, because it's a good approximation of the short distance.
So you're saying that horizontal being straight would get a measurement from the... Oh, wait a minute. You use a tool called a level that establishes a horizontal, and then from that horizontal you measure a vertical change, don't you?
I'm saying that
you do though, don't you? Right? Do you understand that? Right? You use a tool called a level that establishes a horizontal, and you measure a vertical change from that horizontal. And what do we call that vertical change again?
Elevation change. That's not
a reference to the horizontal, obviously.
But I'm in reality, and that's why I'm thinking of actually doing this test. In reality, specifically say that horizontal is actually not a plane. Your misunderstanding of my model is not my problem. It's up to you to understand it.
You don't understand. Hold on.
You don't understand.
I mean, he obviously doesn't understand what leveling is.
It's not my problem if you don't want to learn. You're just on your own.
I have no problem with you all using a water level to establish a horizontal plane. It will be tangent to the curve of the earth. They would maintain the same elevation. But remember, levels occur. So then is a vertical angle just a right angle? Grab a water level, that same water level test, and sight across it. That's it. Anything that is 90 degrees from that plane will be parallel to the vertical that you established at that point. Whenever y'all ask me about surveying, I say, yeah, I'm not an expert. I defer to the experts.
I know, if you carry on, you carry on, but I don't think it's... I mean, he obviously doesn't understand what leveling is. I mean, he obviously doesn't understand what leveling is.
You don't understand.
Hold on. You don't understand.
It's not my problem if you don't want to learn. You're just on your own.
We don't use proof in reality, that's pseudoscience. Or you can use it for math and logic. I don't claim to know anything about the bang.
Have you ever held a water level? Have you ever held a water level?
Have I held a water level, the tool? No, but it's a pretty simple concept.
Say they're even so bold over there, you guys. They believe horizontals are parallel.
Yeah.
Have you ever heard of proof before? Like real
proof doesn't exist in reality. It only exists in math and theoretics.
With your picture, then. Thank you.
No. I'm not trying to prove anything.
Hold on.
No, I'm showing you evidence that the earth is a globe.
Prove stuff.
No, I'm bringing evidence that the Earth is a globe.
Hold on.
Why would I try to prove something? That's pseudoscience. We don't use proof in reality. That's pseudoscience. That's pseudoscience.
Hold on. You don't understand.
I mean, he obviously doesn't understand what level means.
It's not my problem if you don't want to learn. You're just on your own.
My God. 22 years old. They're on the fucking internet talking to people about begging for your model to be real. It's bizarre.
You're just on your own.
Begging for your model to be real.
No logic, no answers to questions.
You don't understand.
You're just on your own.
Begging for your model to be real.
He thinks the zero pressure state in the water is an arc instead of a straight line.
Yeah. I'm not laughing at Tom. I'm laughing at the theoretical conversations. Hey, there's some people who think level is horizontal and they want you all to talk about. And also, yeah, parallel and vertical being 90 degrees from one another. And in math, typically when you establish a horizontal plane, in math, yeah, it's just one horizontal.
Typically.